This is Lakshmi Narayana, Senior Physics Faculty. Today we are going to discuss about the chapter of light. You all are having idea about a light. Okay. In earlier classes, you know what is light and properties, what properties are there. And in today's section also, we're going to cover all the topics. So let's start the section. Today we are going to start with the topics. What are the topics we are going to discuss here? Introduction of light and what are the properties are there, and see here the topics clearly mentioned: reflection of light, image formation by a spherical mirrors, center of curvature, principal axis, principal focus, and focal length, mirror formula. So these are the topics we're gonna discuss in today live sections. Okay, so light is completely the combination of a topic of reflection and refraction, and today section we're gonna go with the reflection of light. Okay, so without any delay we're gonna start the topic. Clear? Next, introduction of light. Introduction of light. So light is a form of energy, right? Light is a form of energy that produces sensation of vision. For example, if you want to see anything, which is the required light is required. If there is no light, even we cannot see what it is present beside us. Okay, the absence of light we cannot see anything, and without light it's not possible to identify the objects also. So the light helps us to see which is present around us. That's why light is a form of energy that produces the sensation of vision. Okay, for example, without a light, can I move there? It's not possible. Maybe I fell down a number of times without a light also, right? So the light helps us to identify that things and identify the objects which are present around us. We see the objects and we can see that things. And what are the topics are there here? What is that reflection of light? We see the objects when light reflected. When we see the objects and things when light is reflected. Okay, so first light placed on the object, then from the object we get light. Okay, so how it is appear to us? First the light strikes the surface. For example, this is an object. How can I see this? How can I see this one, this remote? How can I see? First, for suppose there is no light, can I see that? No, it's not possible. If there is no light, I cannot see. If the light is present, first light placed on the substance, then after reflection. Okay, so light strikes the surface, light strikes the object or a body, and from the object I will get a light. Then I can able to see which is present. Okay, whether it is a remote or pen or box. Okay, first light strikes the surface, from the surface we get light. Okay, next, the importance behavior of light. What, how the light behavior and what type of behavior it is there. So light is the rectilinear property of light, rectilinear propagation of light. So light is having a rectilinear propagation. For example, if I place a candle here, in lower section we already studied about this experiment. If light takes place and I place a number of cardboards here in front of the light, we arrange the number of cardboards parallelly, you make a hole parallelly, then light passes through the holes, right? Then light passes through the holes. If the person is behind the cardboard, then the person can able to see the light of the candle. So how it is possible? If there is one cardboard is upward, is it possible to see? No. So based on this experiment, what we understand here, the light always travels in a straight line. That is one of the behavior of light. And next, second behavior of the light is reflection property. What is another behavior of light? Reflection property. What is mean by the reflection? Okay, when light strikes the surfaces, bouncing back of light. If I throw the ball, it bounces. How it bounces back? Similarly, if light strikes that any substances, either it bounces back or it passes through. That's why the material, as per the light, we divided into three types: transparent materials, translucent materials, opaque materials. So transparent allows the light, like lens, the glasses. Translucent, it partially allows the light. Opaque means it doesn't allow. Here the reflection, whether the object is present or not, or anything present in front of us, how can we say which is present in front of us? Because of reflection property only. Okay, reflection means is simply bouncing of light. Next, refraction, bending of light. See, both reflection and refraction, when it takes place, means reflection takes place in a single medium. Refraction takes place when a light changes a medium. Okay, when light changes a medium. For example, I am taking a one surface. Here it is a one medium, and here it is the second medium. If light travel from one medium to another medium, this is a medium 1 and below is that medium 2. If light changes from one medium to another medium, then it takes place refraction. Regarding the refraction, we will discuss briefly later in another section. Okay. Next, these two ideas explains that mirrors, lens, human eye, and optical instruments. So based on this reflection and refraction property, these are the things we're gonna cover in the chapter of light. Okay. Next one, reflection of light. So from the beginning classes, we know that what is reflection of light. So reflection of light is nothing but light returns back to the same medium. So from which medium it traveled, and it gets back to the same medium. For example, if I am taking a ball here, okay, this is the wall, this is the wall, okay, this is a wall, and this I am taking a ball. If I throw the ball, what happened? Okay, it's some angle. If I throw the ball, what happened? Here it strikes. Okay, here it strikes. So after strikes that, what happened? It come back to the same medium. So which medium, from which medium we throw the ball, it get back to the same medium. That property we called as that reflection of light. Okay, remember carefully, reflection of light is nothing but light returns. Light returns means coming back. Light returns is nothing but coming back to where, from which medium it travel, and get back to the same medium only. Okay, it get back to the same medium. This property we call is the reflection of light. So if I throw the ball, it get back into the same medium. That is called reflection of light. Okay, and where it takes place, the reflection of light, it is highly reflection takes place on smooth and polished surfaces like mirror. If I want to see my image, where I can stand, in front of the wall or in front of the mirror, both are takes place reflection. But the thing you have to understand here, it is where I will get my image, in front of the mirror or in front of the wall. Can you guess where I need to stand to get my image properly? I need to stand in front of the mirror. Why? Because if I stand in front of the wall, there the reflection is irregular. I cannot get my image clearly. If I stand in front of the mirror, that is a smooth and polished surface, then I will get the image. My image is very smoothly, I will get smooth and polished image I will get, and I can see that exactly how the image is there. In rough surfaces, it's not possible. Okay, next. So what are the examples where we use this? So the examples of image formation in mirrors, now we discussed. If you want to see your image, you need to stand in front of the mirror, not in front of the other person, not in front of the wall, and not in front of. If I stand in front of the wall, if I'm asking to the wall, can you give my image? It gives no. Why? Because it's a property of the wall. It's not polished, it's not smooth. Okay, so the image formation takes place by the mirrors and as well as calm water and as well as shiny metals. Calm water means calm water also gives the image. If you see, that in front of the calm water, you will get the image. If someone is throwing the object, what happened? The water is disturbed. The water is disturbed. So now they see the surface, how the surface will be. How the surface will be. How the surface will be. The surface is irregular. So the irregular surfaces will not form a clear image. Remember, if you want to get a clear image, when you will get a clear image, when you get clear image, the clear image formation due to only polished surface. Polished surface. Because of this polished surface, the reflection takes place is that regular reflection takes place. Which type of reflection? Regular reflection. By the regular reflection only, the image is very, very clear. By the regular reflection only, the image is clear. Okay. By the irregular surfaces, you will not get any type of image. Clear? Next, important terms. What are the terms we gonna use here? Incident ray, reflected ray, normal, angle of incident and angle of reflection also. Incident ray. Which ray we called it is an incident ray? Which ray we called it is that reflected ray? Which ray we called it is that normal ray? See, I am taking one plane mirror here. So the plane mirror has two faces. Okay, if it is a plane mirror, it's two faces, right? One side is smooth and another side is that rough. Okay, so let us think if this side is that rough surface and in front is that smooth surface. So the smooth surface will give regular reflection. Which surface will give image? Regular reflection gives images, and this is that rough surface or coated surface or irregular surfaces. Okay, so the irregular surfaces will not form any type of images. Next, I am drawing a one line here, one ray I am drawing here. Can you tell me that what is that ray? Either it is incident or reflected or normal. How can you say which ray it is that? The thing you have to identify here it is that you have to see the direction. Ray means we represented with an arrow. Ray means we represented with an arrow. So you have to identify the direction, which direction it is there, towards or away. If I am taking towards the smooth surface, towards, the direction is towards the mirror. The direction is towards. So how can we identify it is towards or away? Because of arrow. If there is no arrow, we cannot. Okay, because of arrow. Which direction it is there? Towards the mirror. Then it is incident ray. If it is away, see here it is strikes. This is that where it is strikes, that point we called as the point of incident. Where it is strike, that is called point of incident. For example, if somebody is throwing that object, it strikes here, right? It strikes here. So where it is strikes, that is called point of incident. So here it is strikes, that is the point of incident. After striking the point of incident, see the ray direction away from the mirror. So away from the mirror we call is that reflected ray. Understand that? Two rays, incident ray towards the mirror, reflected ray away from the mirror. And what is the normal? Normal is an imaginary line. Normal is nothing but an imaginary line. How it will be? Perpendicular to the surface. How it will be? How it will be? How it will be? How it will be? Perpendicular to the surface. See, here it is that surface, and see, to the surface it is perpendicular. See, for the incident ray, for the reflected ray it is not. For the surface, where is the surface? This is the surface. To the surface, let us take a perpendicular. This perpendicular line we call it is the normal. The perpendicular line we call it is the normal, and it is an imaginary line. Clear? Okay, incident ray reflected ray, normal. And coming to that, next point, angle of incident. So what is mean by angle of incident? The incident ray is there, right? This incident ray make an angle with the normal. The incident ray makes, which ray? Incident ray makes an angle with the normal, that is called angle of incident. If reflected ray also makes an angle with the normal, what we call, that is angle of reflection. What are the angles are there? Angle of incident is the angle of reflection. Sir, how can we identify angle of incident? How can we identify angle of reflection? It means if which ray making angle with the normal, that we have to check. If incident ray is making angle with the normal or reflected ray making an angle with the normal, that we have to see. If incident ray makes incident angle, reflected ray makes reflected angle. Clear? Next, laws of reflection. If reflection takes place, we have some laws. What are the laws are there? Here, what are the laws are there? Incident ray, reflected ray and normal lie in a same plane. Incident ray, reflected ray, normal, all are lies in a same plane. For example, I am taking a book here. Okay, I am taking a book here. Incident ray strikes. Okay, incident ray strikes, and after striking this one, it going back. Reflected ray, and where will be the normal? Here it is the normal, perpendicular to the surface, normal. Where this incident ray, reflected ray and normal, these three are lie in a same plane. That is the first law of reflection. Clear? Incident ray, reflected ray and normal, these three are lies in a same plane is called first law of reflection. And coming to that, second law of reflection. What is the second law of reflection? Angle of incident is always equal to angle of reflection. Very, very important. If you want to do the numericals based on the law of reflection, you have to remember this one. Okay, angle of incident is equal to angle of reflection. For example, see here I am drawing that incident ray, and this is the normal. Okay, normal making angle of 90 degrees with the surface. Here also 90 degrees with the surface. A light ray strikes that. Okay, and this light ray strikes the, makes an angle. For example, let us take this is 60 degrees. Okay, and here also reflected ray also makes 60 degrees. Reflected ray also 60 degrees. So angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection also. If the incident angle is 30, reflection also 30 only. If the incident angle is 45, reflection angle also 45 degrees only. So what is the incident angle? The reflection angle also will be the same only. That is the second law of reflection. Understood? Next, what is an image? What is image? From the comment section, sir, explain once again. Angle of reflection. Okay, see, angle of reflection is nothing but incident ray is there, right? Incident ray towards the mirror, reflected ray away from the mirror. Incident ray, how much angle? For example, reflection angle, I don't know. I don't know the reflection angle. The angle of incident is given 30 degrees. Angle of incident is given 30 degrees. What is the angle of reflection? Say, what is the angle of reflection, guys? Angle of reflection? Yes, 30. Angle of reflection 30. For suppose, if light ray travel along the direction of normal. See, follow here. If light ray travel along the direction of normal, what is the angle of incident? The many students are confusing here. If light ray strikes towards the direction of surface, okay, light ray passing through the normal, what is the angle takes place between normal and incident ray? What is the angle? Anybody? Any from the chat comment box? Anybody? What is the angle takes place between incident ray and normal when the light ray is passing along the direction of normal? What is the angle? What is the angle? angle of incident is equal to 0. Why angle of incident is 0? If angle of incident 0, angle of reflection also 0. Why angle of incident 0? How the light ray, this is the normal and this is the incident ray. How these two will be? How these two will be? Parallel, right? So if the parallel means what is the angle? 0. So when a light ray passing through the normal and the angle of incident 0. If angle of incident 0, angle of reflection also 0. Clear? Clear na? Yes. Next one. What is an image? Image means when image forms, when an image forms, an image is formed when light rays coming from an object. We already discussed in the beginning. Light ray coming from that. From where it has come light ray? First strikes the object. First strikes the object. From the object, light rays coming. Right? So whenever it is coming, these actual light rays meeting or not, that is very important. To form an image, what required? To form an image, what required? Light rays are intersecting or not? How the intersection takes place? Really intersecting or appear to be meet like that? You have to check these two. Really it is meeting at a point or not, or appear to meet at a point, that you have to check. If really meet, okay, the light rays after reflection meeting at a point or not, that you have to check. If really meet or actually meet at a particular point, there it forms that real image. When you will get a real image, when you get real image, the actual light rays after reflection or refraction, the actual light rays are meet at a point, you will get which type of image? Real image. And when the virtual image you will get? For example, if I am stand in front of the mirror, what type of image? If I will go forward one step, in the mirror it shows that one step forward towards me only. Which type of image? Which type of image? There that light rays are actually meeting or appear to be like that, meeting at a point. So there you will get virtual image. Real image means actually meet at a point. There you will get real image. Okay, don't confuse. Real image means actually meet at a point. Virtual image means appear to meet at a point. Appear to meet at a point, it is a virtual image. Next, real image, when reflected rays are actually meet, where it takes place? On the screen. Okay, where it takes place? On the screen. For suppose if you stand at any place, your image is captured on the screen, then that image is real. If you stand in front of the mirror, the image is captured? No. Then what type of image? Virtual. So you see the difference here, right? Which is real, which is virtual. Only the difference is forms on a screen, real. Not forms on the screen, virtual. That's it. No confusion about real and virtual. Forms on the screen or not, we have to check. Forming on a screen, yes, it's a real. It's not forming on a screen, it's a virtual only. Okay. So, and it is usually inverted. Inverted. The real image is that inverted. Virtual image is that erect. Okay. Virtual image appear to meet at a point. Virtual image cannot obtained on a screen. Remember the point. It's a very important. This point will decide. This point will decide it is a real or virtual. Obtained on a screen. Obtained on a screen. Real. Cannot obtained on screen. Virtual. Okay. Virtual. Virtual image is that erect only. Which type of mirror will give that virtual image? Mostly plane mirrors only. Plane mirrors always forms a virtual image. Plane mirrors always forms the virtual image because it not capture on the screen. Clear? Next, look at the question. Law of reflected holds. Laws of reflection. Laws of reflection hold true for which surfaces? Laws of reflection hold true for which surfaces? What is the law of reflection? Angle of incident is equal to angle of reflection. incident ray, reflected ray, normal. Okay. Law of reflection. Law of reflection is nothing but take a surface, smooth surface is there, rough surface is there, light ray incident takes a normal, the angle takes place between incident ray and normal, incident angle, and the angle takes place between reflected ray and normal, angle of reflection. Okay. So the law of reflection hold true for which surfaces? Which surfaces? It is for rough surfaces or smooth surfaces, or plane mirrors or concave mirrors or convex mirrors or any other type of mirrors. It holds for all reflecting surfaces. Don't confuse it here. The law of reflection is true for all type of reflecting surfaces, whether it is rough or irregular or whatever it may be. It is applicable for all reflecting surfaces. Clear? It is clear. It is applicable for all reflecting surfaces. Here the question from the chat comment section. Why it is applicable for all surfaces? Very good question, beta. So why it is applicable for all reflecting surfaces? You are also get the same doubt, na? Sir, previously you said regular only forms that plane, regular only forms that image. Other one it's not forms the image. But here the thing is what? Law of reflection. They are asking about law of reflection. Okay, not the image. Whether it is that real image or virtual, they are not asking about those things and all. They are asking about law of reflection is applicable or not. So it is applicable for all reflecting surfaces. How it is applicable for all reflecting surfaces? If you zoom in, okay, where it is strikes that at a point it strikes. At a point it strikes that. If you elongated that particular point, their angle of incident at that particular point, angle of incident is equal to angle of reflection. It holds for all the surfaces. It holds for that all the surfaces. Clear? Clear? If they ask you next time also, the raw reflection holds for all reflecting surfaces. All reflecting surfaces. Clear? Next, list 4 characteristics of the image formed by a plane mirror. Plane mirror characteristics. Okay, what characteristics plane mirror has? Lateral inversion. Lateral inversion property. If you raise the right hand, in the mirror it shows that left hand. If you raise the left hand, in the mirror it shows that right hand only. Yes, clear. So if you see that the letter of ambulance, how it will be? How it will be letter of ambulance? Why it will be like that? Have any idea? If you see all the letters on the ambulance, how it will be? Why it is like that? Because if you see the thing in the mirror, okay, it will be appear like ambulance. Okay, that is the property of lateral inversion. Raising the right hand, in the mirror it shows the left. Left hand, it shows that right. Clear? Next, it forms that virtual image. Virtual image. Plane mirror cannot capture image on the screen. It always forms the virtual image. We already remember that point. It always forms that virtual only. Next, it forms that erect. It forms that erect. Next, it forms the same size. How the object will be? Image also same only. If I stand in front of the mirror, I will get double. No, right? I will get thin. No. So however the object, the image also will be the same only. So remember the 4 characteristics. It is having a lateral inversion property and it forms that always virtual only. It is that erect property and it forms the same size. Okay. However the object, image also will be the same only. Okay. Next, mirrors and their types. What is mirror? Mirror is a polished surface. Mirror is what, ma? Mirror is what? It is a polished surface. That's why it is called mirror. If you see your image at any place it is possible to see the image? No, only on the polished surfaces. That's why it is called that mirror. So in the mirror, what are the types we have? Plane mirror. Plane mirrors means how the surface will be flat. Spherical mirror. Spherical mirrors means it is a hollow sphere. You know, plane mirrors means is a flat. Spherical mirrors means hollow. So again in the spherical mirror we have two types. How many types in a spherical mirror? Two types. What are they? Concave mirror and convex mirror. So you are confusing about, sir, which is concave and which is convex. How can we identify the difference between concave and convex? Which is concave? How can we identify, sir? Which is convex? How can we identify, sir? Concave means, see, what is another name of the concave mirror, ma? It's a converging mirror. What is another name of the concave mirror? Converging mirror. Why it is called as the converging mirror? Why it is called? Simply they won't call it is a converging mirror, na? Why it is called it is a converging mirror? For example, I am taking a mirror like this. Okay, inner side is smooth. Inner side is smooth and polished surface. Outside is that rough surface. Rough surface I am marking like this. Okay, so where it will be? Where it will be smooth surface? Smooth surface is inside. Smooth surface is inside. Outside is the rough surface. If light takes place, if I am taking a number of light rays, number of light rays, number of light rays, how it will be? How it will be? After striking the point, it will meet, na? After striking the point, it will meet, na? So what happened here? After reflection, see, this is the light ray. This is the mirror. Light rays are coming. Strikes, coming, strikes. So after reflection, what happened? Look at the directions. Look at the directions. How the directions? Going to meet at a point, na? It is going to meet at a point, right? It is going to meet at a point. So that means combining at a point, na? Combining means converging. Converging at a single point. That's why it is called that convergent mirror. Understood? Concave mirror we call it as a convergent mirror also. Why it is? After striking that surface, the reflected rays where it is meet at a point, that is called convergent of light. And divergent means, divergence of light means, here it is that what happening after striking the surface, combining at a point. Divergent means opposite. Divergent means opposite, separated. It will go in different directions after strike the surface. Okay. See here, important terms in the spherical mirror. Pole. What is pole? What is a pole, ma? What is a pole? Pole is the center. Where? On the mirror. On the mirror, pole is a center point. Okay. What is a pole? It is a center on the mirror. On the mirror. Okay. Center of curvature. Okay. What are the center of curvature? If you take a whole mirror, spherical mirror, na, center, it's called center of curvature. Radius of curvature means, radius of curvature, see here, this is the center of curvature, this is the center of curvature. The distance from pole to C, okay, the distance from pole to C is called radius of curvature. The distance from pole to C is called as that radius of curvature. Next, principal axis. What is the next one? Principal axis. The principal axis is nothing but the light ray which passing through the center of curvature and as well as pole. Okay, the light. Okay, light has to pass first center of curvature, then it passes to the pole also. Then that ray we call it is that principal axis. Again we will discuss briefly here. See, pole, central point of the mirror. If you take, this is the mirror, which is the center point. This is the center point, right? Here it is a center point. So this center point we call it is that pole. Next, center of curvature. It means for the whole mirror, for the whole mirror, it is a center point. The center of the sphere of the mirror, which is the part we taken here. Next, radius of curvature, distance between P and C. distance between P and C. C, pole in center of curvature. The distance between pole to center of curvature, what we call radius of curvature. Clear na? The distance from pole to center of curvature, the distance we call it is that radius of curvature. Okay. Next, principal axis, a straight line passing through P and C. Okay, this right line passing through that P and C. Remember all the points: pole, center point on the mirror, center of curvature, it is center for whole mirror, radius of curvature, the distance from pole to C. Principal radius of curvature, distance from pole to C. Principal axis, a line passing through C and as well as P. That is called as the principal axis. Okay. Next, principal focus. Principal focus. Remember the term principal focus. After striking that, after the light rays, after striking the surface, where it meet, that point we call is that principal focus. Okay. It is a point. Principal focus is nothing but, F is nothing but what ma? It is a point. It is a point. Where we'll take that point? On the principal axis. Okay. Where we'll take that point? On the principal axis. How that point will forms? After striking that, I am taking a concave mirror here. See, number of light rays are striking. This is the principal axis because it's passing through the P and as well as C. It passing through C and as well as P only. And see, number of light ray strikes and it converging at a point. Here it is a one point we taken na. This point we called as focus. This point we called as that focus. Okay. Focus is nothing but, it's a point. Where we will take that point? On a principal axis only. Okay. Where we will take that point? On the principal axis. Okay. Where? On a concave mirror. And appear to diverge from a convex mirror. If you take concave mirror, really meet at that point. It's a focus. And if you take convex mirror, it appear to be like that, appear to be meeting at the point because it's diverging. Light rays are diverging here. Okay. Next, nature of focuses. If you take a concave mirror and convex mirror, the difference we have to understand very easily. If you following the section, you can understand that concave mirror and convex mirror differences very easily because concave mirror, how the focus will be real because it really meeting at that point. Convex mirror, it forms that virtual focus. Why it is virtual focus? Because after reflection, how the light rays will be diverging. Remember the point. Concave mirror gives that real focus. Convex mirror gives that virtual focus. Okay. Why it gives real? Because converging of light. Because convergent of light. Why it gives the virtual? Because divergent. Because of divergent, what happened? The light rays are not meet at that particular point. It is appear to meet at that point. That's why it is called that virtual focus. Clear? Next, focal length. What is the next one? Focal length. So focal length is nothing but, we discussed the radius of curvature, center of curvature. What is the focal length ma? Focal length is nothing but the relation between, the focal length is nothing but, here see, here it is F na, okay, F is what? Focus. So the distance between pole to focus, here it is a pole, here it is a focus. The distance between pole to focus is called focal length. Okay. What is mean by focal length? Focal length is nothing but the distance. What distance is takes place between pole to focus? That we call it is that focal length. Okay. Clear? So focal length is nothing but distance between pole to focus. Here we have to see the relation between radius of curvature and focal length also. F is equal to R by 2, then R is equal to 2F. Here it is the relation between pole and focus. Clear na? Concave mirror always gives the real focus. Convex mirror always gives the virtual focus, because I already explained why it gives real when it gives virtual. Real means really meet at that point because of converging. Virtual means it's not meet at that point. Okay, it is a divergent rays. Clear na? Clear? Next, if you want to draw the ray diagram, we have to follow some rules. Okay, it's not by our own way to draw the ray diagrams. Na? We have to follow some rules and regulations are there to follow, draw the ray diagrams are there. So what are the rules we have to follow just to draw the ray diagrams? Okay, the first one is a ray parallel to the principal axis passing through focus. What is the first point, ma? I am taking a concave mirror. I am taking a concave mirror where it is a pole, exactly center on the mirror, and if light ray passes through the center of curvature and pole, what we call, it's a principal axis. It is a principal axis. Now coming to the point, what is the point? A ray parallel to the principal axis. So what is the principal axis? This is the principal axis. I am taking a one ray. How that ray will be? Parallel. See how the ray will be. How the ray will be. How the ray will be. This is the principal axis, and this is the, okay, this is the principal axis, and this is the light ray. How these two will be? Parallelly, right? So a ray parallel to the principal axis. Okay, after striking the surface, what happened, ma? It passes through the, after strike the surface, where it passes? It passes through the focus. Remember, the first point is that if any light ray is parallel to the principal axis, after strikes the surface, it passes through the focus. If any light ray parallel to the principal axis, it after strike the surface, it passes through focus only. Remember, parallel. If light ray is parallel, how it will be? It passes through the focus. That is the first point. Light ray parallel passes through the focus. Next point, if you take a ray, okay, see, a ray through becomes parallel to the principal axis. A ray through center of curvature retraces its path. It means if any light ray, okay, initially we discussed about, if you take a plane mirror, if any light ray passing through the normal, how it will be? Again the light ray retraces, back, right? Retraces back na. How it will be takes place in a plane mirror? Here also the same thing. What is the second point here? I am going to explain here. The second point is that if any light ray passing through the principal axis. So here the principal axis, if light ray passing through the principal axis, what happened? After strike the pole, it reflected back only. After strike the pole, it reflected back. It means how this pole acting here? This pole is acting like a normal. Okay, here also the same thing na. After strike the surface, it reflected back. In a plane mirror, here also same thing only. After strike that pole, what happened? Retraces it back. Clear? Next, a ray through center of curvature retraces path. Next, a ray of incident at the pole. A ray of incident at the pole reflects, make equal angles. Reflects, make equal angles. See here. See here. How it makes equal angles. I am taking here again a concave mirror, and there is a pole on the mirror. If any light ray passes through the center of curvature and as well as pole, what we call, that is the principal axis. And if light ray makes an angle with the principal axis, and here also the same angle, law of reflection is applicable here. Law of reflection, a ray of incident at the pole reflect makes equal angle. See, here angle of incident is 30, here angle of reflection also the same only, here also angle of reflection same only. Next, last one, at least two rays are required to locate an image. How many rays are required? At least two rays. It's not possible with a single light. Is it possible to clap with one hand? Is it possible? Hello? Is it possible with one hand? It's not possible. How can you clap without one hand? With the two hands it's possible. Right? Similarly, if to form an image, how many rays are required? Two rays are required to form the image. Okay? Remember the points again. First one is what? Parallel. If light ray is parallel, after strike the surface, passing through the focus. Passing through the focus. And if any light ray passing through the principal axis, what happen ma? It retraces it back. Retraces it back. Next, if any light ray makes some angle with the pole, and reflection angle also will be the same only. Incident angle is equal to reflection angle. Next, to form that image, how many light rays are required? At least two rays are required. The image is cannot form with that one light ray. I will explain again. See here how it is not possible. I am taking a principal axis. Okay, see, and pole, light ray I am taken, one light ray I am taken, where it strikes, passes like that. So is there any intersection of light ray? There is no intersection of light ray. So it's not forms the image. Okay. So to form an image, how many light rays are required? Two light rays are required at least. With the single light ray, it's not possible. Clear? Clear? Yes. Next, see the ray diagrams. The ray diagrams are very crucial to solve the numericals. Okay. To solve that any type of problems. The ray diagrams you just understand to solve a numericals. What is the first point? What is the first point? Look at here. Where is the object? Where is the object? Infinity. Where is the object? At infinity. How the light rays are there? How the light rays are there? Parallel. How the light rays are there? Parallel. If light ray parallel, where it strikes? After strike the surface, it will meet at one point. That point what we call focus. From the focus to pole, of pole to focus, what we call focal length, we call, that is represented by the small letter f, small f. Okay, see how the light ray, where it is the object? Infinity. Where is the object? Infinity. Where is the image takes place? At focus. Where is the image takes place? At focus. And look at here, second point, look at here, where is the object? See, object is where? Infinity. And second time, see, first case we take the object at infinity. In second case, where we take an object beyond C. Here it is an object. Here it is an object. The object is beyond C. Here it is at infinity. If it is infinity, how the light rays will be? Parallel. If the light rays are parallel, where it meet after strike the surface? It meet at focus. Then you will get image at, where you will get the image? At focus only. How the image will be? A point sized. Okay, highly diminished. A point size image you will get at focus. And here also, where is that? See, object is going towards the direction of mirror. Object is going towards the direction of mirror. Where it is the object now this time? Beyond C, where the image takes place. Where the C? Here it is image. Na? Here we take in a object is AB. Listen carefully here. What is the object we take in? AB. And what happened here? AB. What happened? Look at that. Size of the AB. Like this. And look at the image of AB. How it will be. Here what is the image? Here what is the image? Here object is AB only here also. And what is the image? Here it is very point side, highly diminished here. And here object will be at beyond C. Where is the image you will get? Between F and C. And how the image will be compare both? How the image will be? Here it is. How the object will be? How the image will be compare it is. Okay. Compare beyond C. Where is the image takes place? The position of the image is between C and F. Between C and F. See here. At infinity. At infinity. Where is the image? At focus. Where is the image? At focus. How the size of the image? Highly diminished. Point size. And what is the nature of the image? Real and inverted. Real and inverted image only. Okay. Infinity. Look at here. If B. I means image. Infinity. F means focus. Object at infinity. Image at focus. Object at infinity. Image at focus. Object in infinity, image at focus. Okay. Next, what is the size of the image? Highly diminished image, point size. And what is the nature of the image? Real and inverted. Remember the point. If the object at infinity, where is the image you will get? Where is the image you will get? At focus. What is the size of the image? Highly diminished, point size. What is the nature of the image? Real and inverted. Okay. Next, coming to the second point, where is the object? Beyond C. Where is the object? Beyond C. Where is the image it takes place between F and C? The object is C. Object initially at infinity. Then after what happened? The object is towards the mirror. The object is towards the mirror. And what about the image? If object is coming in this direction, image is trying to do opposite direction. Image is trying to do opposite direction. Just compare these two diagrams. Where is the image initially? If the object at infinity at F the image is there. The object at infinity. If the object at beyond C, where is the image? See, it crosses F na. That means image is going this direction. Object is coming this direction. Clear? Okay. So where is the object? Beyond C. Where the image takes place? Between F and C. And what size of the image? Diminished image only. What is the size of the image? Diminished. And nature? Nature, real and inverted. How the image will be? Inverting image only, inverted image only. Okay. Nature of the image is real and inverted. Next. Now see that. Where is the object? Object tries to do towards the mirror. Remember the point. Object is trying to towards the mirror. Image is that opposite direction. Image is away from the mirror. Object is that towards the mirror. Okay, object is towards the mirror. Image is that away from the mirror. This time, where is the object? At C. Where is the image? Image also at C only. Look at the diagram. Object at C, image also at C only. Now, in this case, what happened? Where is the object? B between C and F. How the object will be C? Here the object is, how the object will be, image also same only. But here, how the object? Object is small. Look at that. Object is small and how the image will be? Increases na. Compare it to that object, image is increases na. So where it takes place increasing the image? If the object is between C and F, the image is increasing. Okay. Look at here. At C. At C. Where is the position of the image? At C only. What size? Same size. What is the nature? Real and inverted. Look at the diagram. Inverted image. Next point. Where is the object? Between C and F. Where is the object? Between C and F. Where is the image? Beyond C. What type of image? Enlarged. The image is enlarged. And what is the nature of the image? Real and inverted. What nature it has? Real and inverted. Clear? Next. Next, look at the diagram. Look at the diagram. Can you guess anybody from the chat box? Anyone? Where is the object now? Where is the object now? Where is the object now? Yes, very good. Where is the object? Object AB at F. Object AB at F. Where is the image? Can you guess? Where is the image? Look at the diagram. Look at the diagram. After strike the surface, the reflected rays, it is meeting at any point? No. It's meeting. How they are? How they are? Parallel it is going. If the parallel rays are meet at a point, never. Then where is the image will form? At infinity. Clear? Where the object at focus, where the image get infinity. Next, look at here. Where is the object? Where is the object? Where is the object now? From comment section, where is the object? Where is the object? Between P and F. Very good. Where is the object? Between P and F. See, here it is P, here it is F. Where it will be? Between P and F, the object is there. Where is the image will be? Where is the image will be? See, behind the screen. Behind the screen. Behind the screen. If the object image takes place behind the screen, what type of image? Virtual image. Virtual image. So the concave mirror, when it gives virtual image, when the object takes place between P and F, when the object takes place between P and F, then the image is virtual. Why it is virtual? Because it forms the image behind the screen. If image takes place behind the screen, it's a virtual only. Clear? Look at that. Object at F. Here the image infinity. What is the size of the image? Highly enlarged. Infinity. Infinity. It's a highly enlarged. And what is the nature? What is the nature? Real and inverted. And the object at P and F. The object at P and F. Where is the image? Where is the image? Behind the mirror. How the image will be? Enlarged. What is the nature of the image will be? Virtual. Virtual and direct. So look at this. Only when you will get virtual image in a concave mirror, they will ask okay, few questions like this they will ask, where from the concave mirror when you will get virtual image. The answer is, the object is takes place between P and F. The object takes place between P and F. The image is virtual. The nature of the image is virtual and direct, and size of the image is enlarged. Clear? Clear? So once we recapitulate all, at infinity, object O, object V, image, object. Where is the object? Infinity. Just remember the 3 points. Just remember the first 3 points. That's enough. Infinity. Where is the image? F. Object infinity. Image F. Now see. Now see. If object at F, where is the image? Infinity. Same na, both are. If object at infinity, image will be at F. If image at F, sorry, if object at F, image at infinity. Object infinity, image you will get F. Object infinity, image F. If object at F, where the image? Infinity. A dash, A dash, A. Object infinity, image F. Object at F, image at infinity. Reverse na? Okay. Beyond C. Object, where it is the object? Beyond C. What is that? Where is the image takes place? F and C. Object at beyond C, image at F and C. Now see, go like this. Where is the object? Between C and F. Between C and F. Where is the image? Beyond C. That's it. Just focus on the 3 points. Next, where is the object at C? Where is the image? C only. Clear? 3 points only. Infinity, F. F is the object. At position of F, object is there. Where the image? Infinity. If the object at infinity, image you will get at F. Okay, both are quite opposite. Beyond C, between F and C. Between F and C, beyond C. If the object at C, image also at C only. Okay, infinity, highly diminished, diminished, same size. See, up to here only, diminished, diminished, same size. After same size, enlarged, enlarged, enlarged. Okay, enlarged. And see, if you take only in case of P and F, only in case of P and F, only in case of P and F, where the image will be? Behind the screen, right? Where the image will be? Behind the screen. And what is the size of the image? Enlarged. And what is the nature of the image? Virtual and erect. Remember the point, very, very important. The point is that in which cases concave mirror gives that virtual and erect. Then the answer is that if the object takes place between P and F, the nature of the image is virtual. Clear? Now see, previously we discussed about a concave mirror and the properties. Okay, where the object, where the image will be. Now, this time we are going to discussing about the convex mirror and the properties of the convex mirror. Clear? So, what is the concave mirror and convex mirror? The differences first we have to see. Concave mirror means the reflecting surface is that bulged inward. Okay, the reflecting surface is that bulged outward. It is a convex mirror. So, that the difference is that the reflecting surface, how it will be, either it is inside or outside, that we have to check. So, see here, I am taking a convex mirror. How I have to identify whether it is a concave mirror or convex mirror? See, this is the surface, reflecting surface. The surface is reflecting surface. How it will be? Okay, reflecting surface. And here it is that this is the rough surface. So rough surface we have to mark. Rough surface we have to mark. See, I am taking a mirror. Rough surface I am marking like this. Rough surface I am marking like this. Okay, rough surface I am marking like this. And see where the object will be at infinity, where you will get image at focus, how the light rays will be parallel. If light rays are parallel, what is the first point then? Rule number 1, if light rays are parallel to the principal axis, where you will get image, either virtual or real image. If the light rays are parallel to the principal axis, where the image you will get? The image you will get at focus only. No? The image you will get focus only. See, at infinity, where the image you will get at focus. See here how the light rays will be striking at this point. Striking at this point. After striking, how the light rays will be? How the light rays will be? Diverging. How the light rays will be? Diverging. Okay. See, the diverging light rays are meeting at the point. Diverging light rays are meeting at the point. See, the object at infinity, between infinity and pole. See here, where is the object position? Where is the object position? Where is the object position here? See how the light rays will be parallel. Na? Where the object will be at if the object is at infinity, in the image you will capture it at focus on. And look at the second diagram, where it is that object, where it is the object position at here. The object position is here, where the image you capture. What type of image is there? When the object is at infinite, finite distance. See here, where the object at infinity, here it is that finite distance. Look at the differences. Object at infinity, where the image will capture. If the object at finite distance, where the image will capture. We have to check. Only two cases are there in a convex mirror. What are they? The object at infinity, where the image will capture. Okay, that is the first thing we have to check. And the second thing is that at a finite distance, not at infinity, at a finite distance. Okay, so in concave mirror we take in beyond C, at C, okay, or like that, wherever you take that, where the it's a finite distance. So where the image will be captured. Only two cases are there in the convex mirror. Look at the table here. The object position between infinity and pole. Where we'll take object position between infinity and pole. So what is the pole? On the mirror. Pole is a point we will take on the mirror. It's a pole. Okay. So where is that object between infinity and pole? Where the image will get? Behind the mirror. Where get the image? Behind the mirror between that P and F. Where you will get? Between P and F. If you takes place the object in between, in between, in between infinity to pole, where you will get the object is in between infinity to pole, where you will get image, where you will get image, the image you will get between pole and focus. Where you will get the image? Between pole and focus you will get image. And if the object at infinity, where you will get? Where you will get? You will get it F only na. For concave mirror also the same, for convex mirror also same. So the first property, if light rays are parallel to the principal axis, either it is concave or convex. If light rays are parallel, it started at infinity. Where it meet? In concave mirror, at focus. There you will get real. Here it is a which mirror? Convex mirror. It is a convex mirror. Where it will meet? Here also it will meet at focus. But which rays are there? Virtual. Why it is virtual? Because the light rays are diverging. After striking that, the light rays are diverging. The diverging one, which one? Diverging mirror which gives? It forms the virtual image only. Okay, remember the 2 points. What are the 2 points? If you take an object at infinity to pole, where is the image you will get? Where is the image you will get? Between pole to focus. If the object at infinity only, the image is at focus. There is no change in that. Object infinity, image focus. In between infinity to pole, where is the image? The image also takes place between pole to focus. And coming to that, nature of the image. What nature it has? Which mirror it is? Convex mirror. What is the another name of the convex mirror? Diverging mirror. Diverging mirror. Diverging mirror means the light rays are appear to meet at a point. If light rays are appear to meet means which image you will get? Virtual image. Okay. So it gives that virtual. And what is the nature of that? Size of the image? Small, erect. Okay. So what nature it is that? Virtual, small and erect. Okay. Virtual, small and erect. And coming to that, if the object at infinity, what is that? Virtual only. And what is the size of the image? Point size and erect image. Remember na? Only 2 points in a convex mirror. The first point is that if you take object at infinity, the image will capture its focus and nature of the image is highly diminished and nature of the images is highly diminished, virtual and erect. And in between infinity to pole, where is the image captures? Between pole to focus. Okay, nature of the image, virtual only. Virtual image, small image and erect. So, if you see the difference between concave and convex, there is no real image in convex mirror. In concave mirror, only one case, it's a virtual image. What is that case? Anybody from the comment section? At what case the concave mirror forms the virtual image? Very good student, very good. Yes, yes. What is that? Where the position? The object is at P and F. Very good. Okay, you're following the section is very effectively, right? So, where is that object? Between P and F. Where is the image? Behind the screen, in concave mirror. What is the nature of the image? Virtual, highly enlarged. Only in that case. The remaining all the cases, concave mirror is that forms the real image only. Clear? Next one. Next. Sign convention. The important one is that sign convention. Important one is that sign convention. Here I will there to help you to get sign conventions and all. Okay. See how to take the sign convention here. The simple way is that how we draw the graph. How we draw the graph. Here we take graph na. Graph positive y axis negative y-axis, positive x-axis, negative x-axis, and here it is that origin. Here it is origin. At origin 0 comma 0. At origin 0 comma 0. So along the positive x-axis all the values are positive. Along the negative y-axis all the values are negative. Along the y-axis, positive y-axis, all the values are positive. Here along the negative x-axis all the values are negative. Clear? So see here, see, coming to the height, remember we will do the sign convention in two cases. Coming to the heights, so heights means you have to see, this is the what, this is the baseline of x-axis, so you have to check whether it is above the x-axis or below the x-axis, because height means we have to check above or below, okay. Don't take it is this is negative side and this is negative side, don't take like that. Coming to the height only I'm talking about only height. If it is above the principal axis, okay, this is the principal axis na, this is the principal axis na. So see, above the height, above the principal axis or below the principal axis, only take these two cases only. Coming to the height, only take two cases. What are they? Above the principal axis or below the principal axis? Above the principal axis, above the principal axis, always positive. Above the principal axis, always positive. Below the principal axis, negative. These two are enough for height. For height, above principal axis, you have to check how the object will be, above or below. Above it is there. Tell me from the comment section. The above the principal axis plus, below the principal axis minus, enough. Coming to the height, above the principal axis, below the principal axis only you have to check. Above the principal axis positive, below the principal axis negative. Next, coming to that direction of incident light ray. See, always we take object left side only na. Object we always take left side of the mirror. Okay, object. See, this is a mirror. Where is the object? Always left side. Always left side. So incident ray, light rays are coming from this direction, right? Light rays are coming this direction, towards the mirror is coming. Okay. So incident ray direction, the direction of incident light ray, if you take, see, distance towards the right side, positive. Distance towards the right side, positive. For suppose I am taking a from pole to at any point here. I measure from pole to point Z. From pole to Z I am taking. Which direction I am taking? Along the direction of incident ray. Then the value of PZ is, positive. Why the PZ is positive? Because I am taking, as per the sign convention, I am taking along the direction of incident ray, positive. Opposite to the direction of incident ray, negative. That's it. Okay. Left side, negative. Right side, positive. Above, positive. Below, negative. Clear? Object will be left side. Clear? Once again you have to see. See. Look at that. Look at the sign conventions. How we take positive, when we take positive, in what cases height will be positive, in what cases height will be negative. What are the direction of incident ray? Along the direction of incident ray what? And opposite to the incident of direction is what? Once see again. See. Incident ray direction of incident ray positive, or if you take a graph like this, positive x-axis positive only along the direction of incident ray, negative x-axis negative only opposite to the incident of direction ray, above the principal axis positive only coming to the height, below the principal axis negative. Okay, object is always left side of the mirror. Clear? Only 5 points. Object always left side, height coming to the height, above positive, below negative, incident ray direction positive, incident ray direction negative. So that means 2 positive, 2 negatives. Which are positive? Above principal axis positive, direction of incident ray positive, opposite to the direction of incident ray negative, below the principal axis negative. Okay, object will be always left side. Clear? Next, focal length. Focal length. What is mean by focal length? Focal length. Look at the side convention. Very important for calculating of numericals. Very important for calculation of numericals. Focal length for concave mirror, negative. Can you guess why it is negative? From the comment section, anybody is ready to tell the answer? Concave, why it is negative focal length? Very good. Very good. Why focal length? Focal length means what, ma? Between, the distance between P to F. The distance between P to F. Concave. I am taking a concave mirror. There is a pole, its center. Where is the focus? Here I am taking a focus. The distance between pole to focus. Okay. Opposite to the direction of incident ray. The incident ray direction is like this. Incident ray direction is like this. Opposite to the direction of incident ray. Opposite to the incident of direction. This is called focal length. So focal length for concave mirror is minus S. For convex, positive. Why convex is positive? Because if I am taking a convex mirror, where is the reflecting surface? Here it is the reflecting surface, and rough surface is like this. Where is the pole? At any mirror also the pole is at center only. And where is the focus? Here it is a focus. Virtual focus. In the beginning we know that where is the focus? Virtual focus is there. So direction of incident ray positive. Clear? Concave mirror negative, convex mirror positive. Next, coming to the object distance. Object distance always negative in concave mirror or convex mirror. Why? Because object, how we can take object distance, how can we take? This is a mirror, this is a mirror, and here it is the object. Here it is the object. Pole to object, pole to object. That means the distance measuring from pole to object. We are measuring the distance is opposite to the direction of incident ray. That's why it is negative. Clear? Clear? Object distance is negative. And coming to the image distance also, image distance is positive for which one? Can you guess? Anybody from the comment section? Image distance is positive. Image distance means pole to image. For concave mirror, which side? For concave mirror, which side? Image will be there. Left side of the mirror only, na? Left side of the mirror means opposite to the direction of incident ray, right? So opposite to the direction of incident ray, negative. Along the direction of incident ray, positive. Okay. So always positive. Exceptional for in front of the mirror. In front of the mirror. Mirror is this side. Image is this side. In front of the mirror, negative. On the same side of the object. The object which side is there? Image also same side, negative only. Clear? If it is concave also, convex also, negative only. Clear? Next, what are the uses of mirrors? What are the uses of mirror? Mostly where we will use mirror? Plain mirror means we will use in daily life. If you want to see how beautiful you are, how handsome you are, right? What mirror we will use? We will use only plain mirror. Okay, if you take concave mirror, sometimes you will be enlarged. Your face will be like this. Sometimes your face will be like this. Okay. So, what are the uses of concave mirror? Concave mirror we will use for shaving mirrors. If you want to save that, okay, shaving, if you want to shave a beard, what type of mirror? Plain mirror we will use. Concave mirror we will use. Why? Because enlarging the face. Okay. And where we will use headlights of vehicles. Okay. Headlights of vehicles. Headlights of vehicles we will use. Which type of mirror? Which type of mirror? Concave mirrors only we will use in headlights. Okay. In next case where we will use in solar furnaces we will use to focus at center on focus. Okay. To focus the light rays at F. The light rays focusing at F we will use solar furnaces, and astronomical telescope also we will use concave mirror. And coming to the convex mirror, where we will use the convex mirror in rear view mirrors. Okay, the most of the times they will ask which type of mirror we will use in vehicles. Rear view mirror. Can you guess anybody why we will use rear view mirror only in vehicles? Why we will not go for concave mirror? Anybody? If you use concave mirror, the image will be enlarged. Exactly. If you use concave mirror, how the properties will be there? Sometimes enlarged, sometimes diminished also there, right? So if the vehicle is coming towards you, if it is appearing like that enlarged, what about other vehicles under? By seeing that only we will scare, right? So which type of mirror we will use? Which type of mirror we will use? Convex mirror use in a rear view mirrors and security mirrors and street lights. Okay, understand the uses na? Concave mirror, where we'll use? Shaving mirrors in headlights, solar furnaces, astronomical telescopes under. And coming to the convex mirrors, where we will use the convex mirror? Rear view mirrors in vehicles. Next, in ATMs and shops we will use, and street lights under. These are the uses of concave and convex mirror. Clear na? Next one, mirror formula. Mirror formula and magnification. Why we use a mirror formula? Is there any importance of the mirror formula? Yes, we have a few importance are there. Coming to the point by point, in a spherical mirror, the distance of the object we will take it is u. The image distance we will take it is u. Okay, object distance is u, image distance is v. Remember that. Object distance u. Object distance means p to object. The distance takes place when p to object. Image distance means the distance takes place from p to image, that is represented by v. Next, what is the focal length? The distance takes place from p to f. Okay, p to object, object distance, p to image, image distance, p to f, focal length distance. Okay, why we all measure from p only? Anybody guess the answer? Why we all measure from p? Anybody from the comment section? No sir, no sir. Yeah, see, if you want to take a graph, from where you measure all the distances. If I am taking a graph here, I am taking a positive x-axis, negative x-axis, positive y, negative y. From where you take all the distances? From the origin. Why? From the origin only we will get all the distances. If you want to get exact one, from all the distances we will measure from the origin only. Similarly, if you want to get that exact value, all the distances measure from pole. So here the pole is act like a origin. Clear? Next, the formula of the mirror. 1 by f is equal to 1 by v plus 1 by u. What is u? Object distance. What is v? Image distance. What is f? Focal length. The distance from pole to f. Okay. Next, magnification. Magnification. What is mean by a magnification? What is mean by magnification? The magnification is nothing but it's a ratio of object distance by it's ratio of image distance by object distance. Okay, magnification is m is equal to minus v by u. Can anybody guess why it is minus? Can anybody guess why it is minus? Why sir? Why we take in magnification? Magnification is nothing but how the image of the object compared to the how the image will be compared to the object. Magnification nothing but how the image will be. If you stand in front of the plane mirror, is there any changes in image? No changes. However, the object image also same. If I stand in front of the plane mirror, how it will be? Same only. If I stand in front of a concave or convex mirror, the difference will be there. So, the magnification is nothing but how the image will be compared to the object. Okay. So, the ratio of image by object we call is that magnification. Then the formula is minus v by u. Okay, the magnification formula minus v by u. Next, magnification is related to the height of the image by height of the object also. Height of the image by height of the object also. We have two formulas in magnification. What are the two formulas? Magnification is equal to height of the image by height of the object. Height of the image by, in terms of height we have one formula, in terms of distances of object and distances of image we have one formula, minus v by u. Magnification m is equal to height of the image by height of the object, and as well as coming to the distances, magnification is equal to image distance by object distance. Okay. Now coming to that next one, the height of the object is taken to be positive. When we will take object will be positive below the principal axis or above the principal axis? Above the principal axis. Above the principal axis positive, below the principal axis negative. Remember the points. Above the principal axis positive. Even in sleep also, if anybody asking about how the object height, positive or negative, you have to check whether it is below the principal axis or above the principal axis. Above the principal axis positive, below the principal axis negative. Clear? Okay. So above the principal axis positive, below the principal axis negative. Okay. Remember blindly. Above the principal axis positive, below the principal axis negative. Next, when you will get positive sign in a magnification, when you will get positive sign, when you will get positive sign in a magnification, magnification m is equal to, what is the formula? Minus image distance by object distance na, image distance by object distance na. When you will get positive sign, when you will get negative sign, what are the signs will be? What are the signs will be? Is there any differences in signs? If it is a plus sign will be there, what will happen? If it is minus sign will be there, what will happen? When you will get plus sign, when you will get minus sign, what is the formula of the magnification ma? Height of the image by height of the object. Height of the image by height of the object in terms of heights, and image distance by object distance. Image distance. What is the image distance ma? Between pole to F. Between pole to F, image distance will be there. Between pole to F, between pole to B, image distance will be there. How will the image distance will be? Minus, minus. How the image distance will be? Minus. How the object distance will be? Minus, minus, minus cancel. We will get V by U. When you will get V by U? When you will get V by U? When the object distance will be minus. In which case ma? In concave mirror object distance we always take minus na. Image distance also exceptional one case, image distance also minus na. So minus by minus what you will get? Positive only na. So if you will get positive, then the image is what? Real image. What is the nature of the image? If you will get positive sign in magnification, real. Clear? So if the magnification is real, okay, magnification value plus or minus, we have to check. Plus, plus, plus real image minus virtual image. That's it. We have to check magnification is plus or minus. Plus or minus. Plus real images minus virtual images. Okay. You have to check magnification plus or minus. Plus. Just remember the signs. Plus or minus. Plus or minus. Plus real. Minus by minus cancel. Real image. Virtual means where the image will be. Where the image will be towards the direction of incident ray na, then the image will be positive, object will be negative. That's why virtual. Clear? Next, coming to the question here, if the focal length of the concave mirror is 10 centimeter, what they given? What they given? First take the given information. Focal length is how much ma? 10 centimeter. For which mirror? Concave mirror. Focal length, how it will be for concave mirror? Take the sign convention, plus or minus. Anybody from the comment section? Sir, focal length will be plus or minus for comment section. Comment section, minus. Yes. Focal length will be minus. For which mirror? Concave mirror. Why it is minus? Because measuring from pole to F, opposite to the direction of incident ray, negative. Focal length will be negative. Now the image formed will be. Image formed will be. Where the image will be? We have many cases, right? If object at infinity, image at focus. If object at beyond C, the object at beyond C, where the image will be? The object at beyond C, where the image will be? Where the image will be? Between C and F na. If the object at C, image at C only. Remember the three cases. Next three cases are C. First case infinity, second case focus, second case beyond C, between C and F, third case object at C, image at C only. Now tell me 4, 5, 6. Reverse. Object infinity, object at C, image at C only. Object at C and F, C and F, image will be beyond C, image will be beyond C. Object at F, image will be infinity. Object at between P and F, exceptional this case, P and F, where the image will be behind the screen, behind the screen. This many cases are there na in concave mirror. They are asking about where the image will be. They didn't mention. Only they given the focal length of the mirror. They not mention where is the object. So without knowing the object, where we can say the image will be formed at this particular point? No idea na. So we have to follow this all. Object at infinity F, beyond C, between C and F. Okay, like this. Clear? Next one. Image formed by a concave mirror is virtual. At what case the image is virtual in a concave mirror? In what case? Concave mirror mostly gives real only, exceptional one case. What is that case? Anybody from the comment section? Anybody from the comment section? Yes sir. Yes sir. The answer is between P and F. The object at B and between P and F, the image is virtual and the nature is enlarged, erect. Clear? It's not formed on the screen. Next one. Next, a negative sign in magnification value indicates that. What it represent? Negative sign. In magnification, what it represent? Magnification, m is equal to minus v by u. Where you will get minus? For which one? For concave only na? For concave only na? Concave will get minus na? Concave will get minus na? So, a negative sign in the magnification value indicates that the image is. So, image is what we have types: real image and virtual image. Okay, real image, virtual image. Okay, real image. So, real image means u negative, v also negative, m is equal to v by u, positive. M is equal to v by u, positive. Here, virtual, u negative, v positive. Then minus v by u. So, where you will get minus? Where you will get minus? Huh? Which type of is this? This is the real. If you get positive, real, and here it is that virtual. So, where you will get virtual? The magnification value indicates that negative. Negative means which type of image it is that? In a concave mirror, it is virtual. Clear? Clear? Next, if the size of the object is given is 5 centimeter, object size is given h naught 5 centimeter, and the magnification value also is given. See, object height is 5 centimeter and magnification by the mirror is 0.5. That means what happened here? What happened? The size is decreases. Magnification is 0.5 and size of the image hi. What is the formula? M is equal to height of the image by height of the object. Substitute the value. Magnification value 0.5. I am writing 1 by 2. 1 by 2 into h naught na. That is equal to hi. Okay. Magnification into h naught. Height of the object is equal to height of the image. So 1 by 2 into height of the object, how much? 5. Then height of the image will be 2.5 centimeter. That is equal to height of the image. Clear? Clear? Next, an object is placed at a long distance. Where the object will be? Where the object will be? Long distance. Did they mention any distance? No. Then take infinity. Long distance means infinity only. Before that any is there? No. So, the long distance means the object is at infinity in front of a convex mirror. Convex mirror. So, convex mirror. Here it is a pole. Focus. Center of curvature. Object, where is the object? Where is the object? A long distance. Where is the object? Long distance. Long distance means infinite only. Infinite only. The object at infinite distance. Radius of curvature is given. Radius of curvature is given. Radius of curvature is nothing but r is equal to how much ma? R is equal to 30 centimeter. R is equal to 30 centimeter. From the radius of curvature we will get r is equal to 2f na. Relation between focal length and radius of curvature, r is equal to 2f. Then f is equal to, if you want to get the value of f, then r by 2. F value is that 15 centimeter only. So now take the sign convention. R is positive or negative, f is positive or negative. R value is how much ma? R is positive or what? Positive only. Why? Because the incident ray direction is this direction. The direction of incident ray we are taking from pole to f, pole to C, along the direction of incident ray only. So R also positive, F also positive. Okay, what we need to find out? State the position of its image. So we need to find out the image. It means we need to find out what is the formula. What is the formula? Mirror formula. 1 by F is equal to 1 by V plus 1 by U. Object. Here is the object. We need to find out V. F value we know 15 plus 15 or minus 15 plus 15 y plus 15 because along the direction of incident ray. Object distance we know, image distance that only we are going to find out. Object distance is what? Minus infinity, minus infinity. Then image distance will be, where is the image ma? Which side? Which side? The object at infinity, image will takes place at focus na. Image will takes place at focus na. Long distance means object at infinity, image will takes place at focus only na. Then 1 by v is equal to 1 by 15 only, plus 15 or minus 15, obviously plus 15 only. Why plus 15? Because pole to f along the direction v value plus 15 centimeter. Clear? Clear? Clear na? Clear na? Yes. Yeah. So now we will summarize this all the topics what we discussed here. Okay, I hope you all understand the topics very clearly in this section, and the next section, refraction of light, will be start very soon. Okay, so what will there discussed in today's live section ma? Introduction of light. So what is light and what are the characteristics it has, what properties it has, rectilinear property, reflection are discussed. Okay, and what is a reflection are there, what type of reflection, regular reflection or irregular reflection, where you will get real image, when you will get real image, when you will get virtual image. Okay, real image means reflected rays are actually meet, the difference between real and virtual meeting or not, that we have to identify. Okay, really meeting means it's a real, it is appear to meet like that means it's a virtual. Okay, so that is the difference between real and virtual. And coming to the spherical mirrors, what are the types are there in spherical? Concave and convex. Concave means bulged inward, reflecting surface is inward. Convex means reflecting surface is outward. Okay, next, center of curvature, it's a whole mirror, it's a center, principal axis, the ray passing through the pole, and as well as center of curvature. Okay, so focal length, the distance takes place between P to F, and mirror formula 1 by F is equal to 1 by V plus 1 by U. Okay, and magnification, so magnification is nothing but what ma? Compared to the object, how the image will be, whether it is increasing or decreasing. Okay, whether it is increasing or decreasing in the magnification, when you will get plus value. Now I explained very clearly, when you will get plus value, when you will get negative value. Okay, when you will get plus value, when you will get negative value. We have two formulas in magnification, in terms of heights, in terms of distances of the object and image. Now the second section of light is refraction. Okay, so you all know what is refraction. Okay, what is reflection, you know, refraction, you know, rectilinear propagation of light. So these all are what? It's the properties of light. Okay, light transfers in single medium. Okay, go from one place to another place. How it will be? It's very straight. Okay, it's a very straight power. How we release an arrow. Okay, so like light also will go in a straight path. And coming to the refraction, in the refraction, this is the topics we're gonna cover in today class. Okay, what are the topics are there? See once what topics are there we're gonna discuss in today class. What are they? Refraction of light. Okay, and laws of refraction. So refraction of light means what is mean by the refraction of light. In refraction, what are the laws are there? Okay, and then after refractive index, then after refractive index, and refraction by spherical lenses. Okay, if you use lenses, how the refraction will be? How the, if you are using any object or any obstacle or any transparent material, how the refraction takes place? Okay, so here refraction of spherical lenses. Next, lens formula. Next, lens formula. So we are taking a lens for see the objects and things, right? So here we will discuss about lens formula and then after power of lens. So if any person, if the person is having any defect, they will use spectacles, right? Which type of lens they will prefer? How they will calculate that which defect it is there and what type of power they have to use? Lens, we go with the power. Okay, everybody have same power. Some persons can see long distances, some persons cannot see short distances, some persons can see short distances, some persons cannot see long distances. For these two people, can we use same lens, same kind of lens? No. So how can we decide? It depends upon power. Okay, yeah, can we go to the topic? Look at the topic. Light travels in a straight line. Light travels in a straight path. Light always travels in a straight path. Why? Light travels in a straight path. Okay, when it travels light in a straight path, whenever light in a one medium, okay, actually there is no required of medium. Okay, if I want to go from one place to another place, what is required? A transport is required. Actually, for the light, no need of any medium. No need of any medium. So, if light travels in one medium, light travels in one medium, how the light will be? Straight path. If light travels only in air, it straight path. Only in water, it's straight path. So if you take any one medium, in that one medium, how the light will be? Straight path. Okay. Next, coming to the next point, when light passes obliquely from one medium to another, remember the point, one medium to another medium. Okay, one medium to another medium. For example, I am taking it two mediums here. One is air and other one is the water. One is air, other one is water. Two are two different mediums. Okay, here I am taking a surface. This is a surface. It's a boundary of these two surfaces. This boundary is separating air. This boundary is separating air and as well as water. Whenever light traveling from either air to either air to either air to water, what happened? Two different mediums are there. How the behavior of light here? How the behavior? The light takes place bending. When the light bends, whenever light travel from one medium to other medium, the refraction takes place. Remember what is mean by refraction? The refraction is nothing but bending of light. What is meant by refraction? Refraction is nothing but bending of light. When a light takes place bending, whenever travels from one medium to another medium, light travel from one medium to another medium, it takes place bending. Okay, that property we call it is that refraction of light. What is the refraction of light? Whenever light travel from one medium to another medium, refraction takes place. See, whenever light traveling from air to water, what happen? Just to draw the normal. Normal is what? It is an imaginary ray. It is an imaginary ray. It always perpendicular to the surface. Okay, it is an imaginary ray. It always perpendicular. That means how much angle? With how much angle it is there? 90 degrees with the surface. See, here we take in a normal. Whenever air to water, light traveling, what happens? See, this is the actual direction of light ray. Okay, air we call it is the rarer medium, and water we call it is that denser medium. Here you have a confusion about what is rarer and what is denser. Rarer medium means where the light go fast. Okay, in which medium light go fast, it is called rarer medium. Where the light goes slow, that is called denser medium. Okay, light is moving fast, rarer medium. Light is moving slow, denser medium. So remember, what is rarer, what is denser means? Rarer means moving very fast, moving very fast. Okay, if I'm take air, or if I'm taking glass, where the light go fast, where the light will go fast? In air or glass? Air na? So air is a rarer medium. And glass, what about a glass? Glass is the denser medium. Okay, so why light goes slow in that particular denser medium? Because of the molecules or atoms. Okay, so whenever light travel from rarer to denser, here light traveling from air to water. Air is a rarer medium, water is the denser medium. See, when it is entering light from rarer to denser, the ray towards the normal, the ray towards, this is the actual direction, this is the actual direction of light ray. But what happened? It is acting towards the normal. Okay, here it is bending now. This bending property we called, this bending property we called refraction. A bending property is called refraction. So refraction depends upon what? It depends upon the nature of the medium. So which medium you are taken? Either it is solid medium. In a solid we have a types. You take in plastic or paper or glass. So it depends upon that particular material. Okay. Here you understand now what is mean by refraction. Okay. Next. See, laws of refraction. What are the laws are there? If you are applying a refraction, the refraction takes place. What are the laws are there in the refraction process? Here we have two laws. Okay, look at the first law, incident ray. So incident ray means the ray towards the surface. If you take this is the surface, okay, towards the surface is incident ray. And refracted ray, where the refracted ray takes place in a second medium. In second medium, this is the actual ray, this is the actual light ray. Okay, and it is acting towards the surface. This is called refracted ray, refracted ray. Okay, and in first medium, which is this incident ray. How can you identify which is incident, which is refracted? Incident ray means towards the surface. See, direction is like this, towards the surface. Okay, and this is the actual direction, this is the actual direction. But whenever it is changing a medium, it is towards the normal. Okay, this is the refracted ray. And normal, and normal, incident ray, refracted ray, normal, these all are lies in a same plane. This is the first law of refraction. What is the first law of refraction? Incident ray, normal, refracted ray, all lies in a same plane. Okay, you can remember with a shortcut also, rin, rin, refracted ray, incident ray, normal, these three lies in a same plane. Okay, next coming to the second law of refraction. This is very 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 important for for numericals or conceptual also. Okay, what is the second law of refraction? See, for a given pair of medium, which pair we taken? Medium 1, medium 2. It's a combination, it's a pair of medium. Okay, the pair of medium, the ratio of sin I by sin r is equal to constant. What is the second law of refraction, ma? The ratio of sin I. Sin I is nothing but what? Here the incident ray makes an angle with the normal, that is called incident angle. The refracted ray which is in the second medium, this refracted ray also making an angle with the normal, that is refracted ray. Okay, so here we take sine angle sin I, here also we will take sine angle sin r. The ratio of these two, the ratio of these two, we call it is that constant. The ratio of sin I by sin r is equal to constant. Okay, this formula or this one is proposed by the Snell's law, that's why it is called Snell's law. Okay, this one is proposed by Snell, that's why it is called Snell's law. Okay, remember that, remember that. What is the Snell's law? What is the Snell's law? The ratio of, okay, the ratio of incident angle by refracted angle, sin I by sin r, sin I by sin r is constant. This law we call as that Snell's law. Okay, now we take in a constant na. Now we take in a constant na. What constant? The ratio of sin I by sin r, we call it is that refractive index. Remember the name, refractive index. So what is the use of this refractive index? Why? For example, here we take in air to another medium. It is internal light. How much bending takes place? How much bending takes place? Who will give? Refractive index will give. Okay, whenever a light changing from one medium to another medium, you will get the ratio of sin I by sin r na. The value you will get na, sin I by sin r value you will get na, that is called refractive index. This refractive index is decide how much bending takes place. This much bending or this much bending or this much bending, who will decide? Refractive index. Okay. Okay, now see, refractive index is nothing but it is the speed of light in two media. Okay, two media. Why it is in two media? In one medium, the refraction cannot take place. Refraction is nothing but what? Whenever light changing from medium 1 to medium 2, two mediums are required. If it is one medium, there is no refraction. Okay, for refraction, two mediums are required. Next point, it indicates that change in direction of light. Changing direction of light. See here how the direction will be. This is the actual direction of light ray. When there is only one medium, this is the actual direction. But whenever it is entering another medium, what changes? What changes? Direction only changes. Direction changes. Okay, and speed changes. Okay, speed changes, direction changes. What it is constant? Frequency is constant. Remember, frequency is constant whenever a light changes from one medium to, whenever light travel from one medium to another medium, what is constant? Frequency is constant. What changes? Velocity changes, direction changes, displacement changes. These all are changes. What is the constant? Frequency is constant. Okay, next, light travel fastest in vacuum. Light travel very fast in vacuum. Why? Why light travel this much fast in vacuum? Because here space, nothing is present. In space, nothing is present, no molecules or no atoms. That's why it is traveling this much fast. Okay, speed of light in vacuum is how much? 3 into 10 to the power of 8 meter per second. Okay, and slow in air, glass and water. Why it is slow in glass and water? Because of, we already decided that it depends upon the nature of the material. If material changes, speed also changes. Okay, next, if you take two mediums, okay, if you take two mediums, whenever light traveling from medium 1 to medium 2, medium 1 to medium 2, here we calculating that refractive index of second medium with respect to first medium. For example, in classroom, you get marks. Okay, you comparing with your friends na, how many marks you scored, whether higher or low. Okay, how you takes place comparison. Even your parents asking also, how many marks you scored? I scored much marks than my friend. You say like that na. So here also the comparison takes place. The comparison, the refractive index of the second medium with respect to first. Okay, the refractive index of the second medium. Okay, medium 2 with respect to 1. So how can we calculate that ratio? Speed of the light in medium 1 by speed of the light in medium 2. Okay, how can you calculate the refractive index of second material? I am getting good marks in physics compared to my friend because I am following that at easy classes. Here comparison is there na. Okay, so here also the second medium refracting with respect to first medium. How can we calculate the refractive index of the second medium with respect to first? Speed of the light in medium 1 by speed of the light in medium 2. Okay, and coming to that, if the same thing, if light travel from 2 to 1, if light travel from 2 to 1, what will happen? 1 to 2 we taken the refractive index of second material with respect to first. And here the refractive index of first material with respect to second one. Okay, how can we calculate? Similarly, speed of light in medium 2 by speed of light in medium 1. Okay, see here we taken it two mediums, medium 1 and medium 2. Where to where light traveling? Where to where traveling? From first medium to second medium the light is traveling. For example, I would like to calculate the refractive index of second material. Which formula I have to take? Tell me, anybody from the comment section. I need second refractive index of the second material with respect to first. Anybody from the comment section? Anybody from live? Hmm? Second material refractive index is required. Second material refractive index. Okay, my marks are required comparing with respect to my friend. How many marks I scored? If my friend compare with me, that is also refractive index of that particular person with respect to me. Clear? Okay. So see, light traveling from first medium to second medium. Okay, if I would like to calculate the refractive index of the second medium with respect to first, then I will write refractive index of second medium with respect to 1. That is equal to speed of light in medium 2 by speed of light in medium 1. Okay, if you take 1 to 2, 1 to 2, 1 to 2, reverse, invert speed of light in medium 1 by speed of light in medium 2. Okay, if you calculate, if you multiply these two, speed of 2 with respect to 1, speed of 1 with respect to 2, what you will get? You will get 1. It's equal inverse. It is inverse. Okay, clear na? Okay na? So if you want to calculate that refractive index of any material, means what we have to do? Compare with other material. Okay, I would like to calculate. Okay, I am saying that my marks are more. How should I know? I comparing with other, right? So here also the same thing. Okay, next, for light traveling from air to medium, where to where light traveling? Where to where light traveling? Light traveling from air to medium. Okay, air to medium it is traveling. So what is C here? C is the speed of light in air and V is the medium. Okay, speed of light in medium. C is what? Speed of light. Okay, we take now medium 1 by medium 2. If you want to find out refractive index of medium, means how can we take refractive index of medium? Means how can we take? How can we take refractive index of speed of light in air by speed of light in medium? So refractive index of medium with respect to air. air. Okay, speed of light in air by speed of light in medium. Okay, air speed of light we taken as c, medium we taken it as v only. Clear? Clear? Refractive index of medium if you want to find out means speed of light in air by speed of light in medium. Okay, next one. Look at here, activity. Activity, what activity is this? What activity is this? Refraction of light through a rectangular glass slab. Okay, which one we taken here? Which one we taken here? Rectangular glass slab. Okay, see here. See here, like this will be rectangular, rectangular glass slab we take it here. Okay, so activity, look at the activity, look at the activity. What happened here? First light entering. Okay, let us take into two surfaces. This is the surface 1 and this is the surface 2. If you compare the first and second surfaces, how the two surfaces will be? Both are parallel each other, right? First surface and second surface both are parallel each other. Okay, look at 1 2, how these two will be parallel each other. Where is the first surface? Above the first surface air, and below the second surface also air only. Okay, so air to glass, rectangular glass slab na. So where to where it is entering? Air is one medium, glass is another medium. So light entering from air to glass. So here it takes place refraction 1. Here it takes place refraction 1. So why refraction 1 here? Air to glass, two different mediums. Whenever light travels in two different mediums, refraction takes place na. That only we discuss it, right? When the refraction takes place, whether light changes its medium or not, we have to check that first. If you want to calculate the refraction, whether the light is changing a medium or not. Here medium changing or not? Yes, changing. Air is one medium, glass is another medium. Which is rarer? Which is denser? Tell me anybody from comment section. Which is rarer? Which is denser? Yes, air is a rarer medium. Glass is the denser medium. Air is rarer. Glass is denser. Air is rarer. Glass is denser. So air to glass. What happened? This is the actual direction of light ray. This is the actual direction. See, the imaginary ray is there now. This is actual direction. If the glass slab is not there, how it will go? It go like this, straight line, because only one medium is present. Only one medium is present. It go straight line. Only one medium, because of one medium. It goes straight line. But glass slab is there now. It is second medium now. Whenever it is entering into second medium, what happened? Draw a normal. Draw a normal. Draw the normal. See, it is towards the normal. Look at that angle, this angle and this angle. See, see, this angle will be more na. This angle is more. See, this is the actual direction of light ray. But whenever it is entering into the another medium, towards the normal. Towards the normal. Look at that. Towards the normal. Okay. Why it is towards the normal? Because light travel from rarer to denser. Remember, rarer to denser. When light travel from rarer to denser, how that light ray will be? Towards. Remember, towards. When light travel from rarer to denser, it is towards the normal. Okay. And look at here. Look at here. This is the incident ray, and the incident ray forms an incident angle that we take in as I1. And the refracted ray also making an angle with the normal, that is refracted angle. So I1 R1 are what? So I1 is incident angle, R1 is refraction angle. Okay, is completed? No. Again light ray traveling to the second surface of the glass slab also. In this case, see, glass slab to glass slab to glass slab to air. Again, glass slab to air. See what happened here? What happened? Glass slab, denser medium, air, rarer medium. So in this second case also refraction takes place. How many refractions are takes place here? Two refractions. Refraction 1 with the first surface, refraction 2 with the second surface. Refraction 1, air to glass. Refraction 2, glass to air. So glass is the denser medium. Glass is the denser medium. Air is the rarer medium. So denser to air it is travel. Denser to air it is travel. See, denser to air, incident angle, this is the incident angle, make an angle with the normal incident angle and extended the normal. Refracted ray also make an angle, refracted angle. So I2 R2 are what? I2 is the incident angle with the second surface. I2 is the incident angle with the second surface and R2 is the refracted angle with the second surface. And look at that ray, look at the ray away from the normal, away from the normal, towards the normal or away from the normal? Away from the normal. See, the actual direction is like this. But what happened? Away from the normal. Away from the normal. Why it is away? Because light travel from denser to rarer, it acts away from the normal. Clear? Rarer to denser. Remember the points I am writing here. Rarer to denser. Rarer to denser towards the normal. Rarer to denser towards the normal. Denser to rarer. Denser to rarer. How it will be? Away from the normal. Remember the points. Okay, if you want to calculate rarer to denser towards the normal, denser to rarer, away from the normal. Okay, how this light ray will be? This is the actual ray, right? This is the actual ray. And the emergent ray which is out, what we call that ray? Emergent ray. So how the emergent ray with the actual ray? Both are parallel. Na? See, if I draw that one normal, okay, one perpendicular line, how these two will be? How these two will be? Parallel. So it means if a light ray travel with the two parallel surface, the incident ray, the actual incident ray and emergent ray which is coming out, both are parallel each other. Clear? Okay? Incident ray and emergent ray both are parallel each other. When the two surfaces are parallel, in this case only. Okay? And it depends upon the incident angle also. Clear? Clear? See, the light ray at point O enter from rarer to denser medium. Rarer to denser medium. How it will be? Bent towards the normal. We discussed that only, na? Rarer to denser towards the normal. Denser to rarer away from the normal. Okay? Denser to rarer away from the normal. How that emergent ray and the incident ray, how these two will be? Parallel each other. Emergent ray and incident ray both are parallel each other. Okay? And next one is that, see, here few materials refractive indexes are there. Okay? Which one is having greater refractive index and which is having less refractive index? We have to observe these two because in multiple times they will ask in examinations and that. Okay, which is the greater refractive index? We cannot remember all, but we can remember in classroom also who is the topper and who is getting less mark. These two only will identify. Okay, the rest of the students they won't focus who is the topper and who is getting less marks. These two only in a classroom, right? Even in your class also will do the same thing, topper and slowness, so whatever the remaining and all, like the table only. Okay, see which is that highest refractive index? Look at that, Where the highest refractive index, which material having? See, look at here, 2.42. Which one? Diamond having more refractive index. Okay, diamond is the topper in refractive index. And which is less? And which is less? Look at that, which is less. Air is having less refractive index compared to other materials. Okay, so that's why the speed of light in air approximately we will take 3 into 10 to the power of 8 meter per second. Remember that? Remember that? Air refractive index and diamond refractive index. So what is the refractive index of diamond? 2.42. Refractive index of air 1.003. Approximately you can take it is 1. Okay, and the speed of light in air is that approximately we can take 3 into 10 to the power of 8 meter per second. Okay, can we go for next one? Yes. Now this time we have a problem. Okay, so don't worry about the problem. Okay, if you worry, the problem become problem only. Okay, so listen here. What is the given? What is the given information? The velocity of light in glass is 2 into 10 to the power of 8 meter per second. First of all, if any problem is given, write the given information. So from the problem, what is the given information? So the speed of light or velocity of light in glass is velocity of light in glass. How much? They given it is 2 into 10 to the power of 8 meter per second. Okay, and then air velocity of light in air. How much that is? 3 into 10 to the power of 8 meter per second. So two velocities are given. One time the light travels in air, that how much? 3 into 10 to the power of 8 meter per second. And the next time the velocity where that travel, it travel in glass. How much it is? 2 into 10 to the power of 8 meter per second. This is the given information. And the next, how much would an ink dot appear to be raised when covered by a glass plate of 6 centimeter thickness? Okay, if you take, okay, for example, I am taking this book. I am taking this book. There are few names right here. There are few names, right? So see how what is the distance between me and this? Let us take it is x. Okay, x distance is there between book and me. Book and me also x distance. With the letters also, how the distance will be? X only, no change, right? In between me and the book, if I will place a glass slab, how it will be? It appears like that the words rises. Okay, if you see a coin under the water, how it will be? The coin is above the surface. It is appear like that, right? So here also, if the dot is there, see, here I am taking a glass slab and this is the surface. Okay, this is the surface. On the surface, ink mark is there. Glass slab we are using. Glass slab we are using. So what is the thickness of the glass slab? What is the thickness of the glass slab? 6 centimeter. So by using this 6 centimeter glass slab, how the ink appear will, let us take it is some point. Okay, I am taking this is the point x. From here to here, it rises x. Okay, so that x we are going to find out. So by using glass slab, how much distance it rises, that you are going to find out. Okay, so we taken all the given information. We taken speed of light in glass. Okay, and speed of light in air also. What are we going to find out? What are we going to find out? Find out that how much when the covered by glass slab 6 centimeter thick, that how much would an ink dot appear. So how much height it appears, that we are going to find out. So first find out the refractive index of the glass slab. Because of this glass slab only na, it rises. If there is no glass slab, it will be appear how much distance there between the person to ink dot only. But when you using glass slab, how it is appearing? the ink dot is rise like that, it is appearing because of glass slab. So the glass slab refractive index you need to find out, because as per the refractive index only how much rises or how much fall down, it depends. Okay, so refractive index, what is the formula? Speed of light in air by speed of light in air by speed of light in medium. Okay, speed of light in air by speed of light in medium. So 10 to the power of 8, 10 to the power of 8 get cancelled. 3 by 2, 1.5. So the glass slab refractive index is 1.5 centimeter. 1.5 centimeter. But what we required? We required how much would an ink dot appear. Okay, what is the apparent position? What is the actual position is what? Actual position is what? 6 centimeter. Apparent position is what? That we don't know now. So by using glass slab, how much rises? How much rises? See, apparent position. Apparent position is equal to real height by refractive index. Real height is 6, refractive index is 1.5. Okay, real height is how much? 6 centimeter. 6 centimeter. So by the glass slab, what is the refractive index? Is 1.5. Then 1.5, 6, 4 centimeter. So this is the apparent position. Where it will be? Where it will be? Where it will be? It will be at 4 centimeter. Where it is the apparent position by using glass slab. If you without a glass slab 6 centimeter, by using glass slab how much it rises? 4 centimeter. So the normal position. If you are seeing like this, the normal position will be there now. Okay. So normal position. Normal. Okay. Normal is equal to real minus apparent. Real how much? 6 centimeter. Apparent is 4 centimeter. Then the normal is 2 centimeter. Okay. How much would an ink dot appear? 2 centimeter. Right. Okay. The apparent position is 4 centimeter. And glass slab thickness is 6. 6 minus 4. The normal we can see it is at 2 centimeter. Okay. Clear na? Clear? Can we go for next one? Next, write the given information for this question. Write the given information for this question. A ray of light, okay, is incident at an angle of 60 degrees. Okay, let us take, okay, incident angle. How much it will be? How much it will be? Incident angle is 60 degrees. Incident angle is nothing but with the incident ray, how much angle takes place. The normal, with the normal, how much angle takes place the incident ray. Okay, the incident ray takes place an angle with the normal, we call incident angle. How much from the question? 60 degrees. On one face of a rectangular glass slab. So let us take rectangular glass slab. So this is the first face of the rectangular glass slab. So with the first face, how much angle? 60 degrees. And what is the thickness it is? So let us take the thickness is 0.1 meter. Okay, on the surface. 0.1 meter. And refractive index. So we no need to find out the refractive index. In problem only they give a refractive index. How much? Refractive index is 1.5. Okay, calculate the lateral shift. What is that? Calculate the lateral shift. See, lateral shift means what, ma? Here, which are the parallel ray? Which are parallel here? Emergent ray, incident ray are there, right? This is the actual direction of the light ray. But what happened? Shifted to here, na? Okay, this is the actual direction of light ray, but shifted to here, na? This shifting we call as the lateral shift. Okay, Here, this is the actual direction. This is the actual direction. Okay, here to here it is shifted, right? So this shifting we call as the lateral shifting. Okay, so that lateral shifting we are going to find out here. What we are going to find out? Lateral shift L. We are going to find. Okay, we have a formula on based on lateral shift. Lateral shift L is equal to T into sine of sin I minus sin R by cos R. This is the formula for lateral shift. Remember the formula? Lateral shift L is equal to T into sin I minus sin R by cos R. Okay. See, did we know? Did we know sin I value? Sin I value we know how much? Incident angle only. Na? Sin I is nothing but incident angle only. So sin 60 that we know. Okay. Next, we know sin R. We don't know sin R. But how can we find out sin R? How can we find out sin R? Is there any relation between sin I and sin R? Okay. Is there any other information is given? We have a information. We have a information. Refractive index also given. Na? Given refractive index also, right? So, refractive index sin I, sin R. What is the value we have? By using these three, refractive index, sin I, sin R. Is there, do you remember any formula? Anybody from the comment section or chat box? Anybody? Anybody? Hmm? Yes, Snell's law. What we call it is that Snell's law. Okay. So, what is the Snell's law? What is the Snell's law? Constant. The refractive index n is equal to sin I by sin R. Na? That only in the formula. That only anybody from the comment section. This only in the formula. Yes, this only the formula. Okay, sin I. So we know sin I and refractive index also we know. Which one we don't know? Sin R we don't know. Then sin R is equal to sin I by refractive index. So sin I value. So sin 60 value 0.85. Okay, and refractive index value. Refractive index value how much they given? 1.5. That only na refractive index. That only na 1.5 only na they given. So if you are calculating how much value you get, 1.5 by 0.8. Let us take it is 9 approximately. 0.6 will come na. 0.6. So 1.5 0.85. So 0.57. 0.587 is what ma? Sin R. That only na 0.57 only na sin R. Then R is equal to sin inverse of 0.57. That only na anybody from comment section. That only na sin R is equal to 0.57. Then find out the value of R. Find out the value of R. R value is equal to 35.2 degrees. Okay, what is the refraction angle? See, air, rarer medium, entering into the glass, denser medium. How it will be? Anybody? This is the actual direction of light ray. This is the actual direction of light ray. Anybody from the comment section? Anybody? Anybody? Anybody from the comment section? How it will be when light travel from air to denser medium? Towards or away? Towards or away? Anybody? Towards or away? Okay, denser na? Towards the normal. So this is the refraction angle. Okay, how much the refraction angle? 35.2 degrees. So we know all the values na? By using lateral shift formula. T we know 0.1, sin I 0.85 minus sin R 35.2, cos R also 35.2 only. So substitute all the values. Substitute all the values. L is equal to T value 0.1, sin I value 0.85, sin R value Sine of 0.85. Sine of 0.85. Sine of 0.85. Sine of 0.85. Sine of 0.85 minus sine or sine of 35.2. Okay. By what is the formula? Cos r. By cos r. R value cos of 35.2 degrees. Okay. So substitute all the values. What they given? T value is given 0.1, we substituted. Sin a value sin 60 we taken. Okay. 0.85 and we substituted sin r value 0.57. Okay. Sin sorry sin 60 sin 60, let us directly substitute the value. Sin 60 sin 60, okay, minus or else the value is also same one, sin 60 0.85 na, sin 60 0.85 na. Substitute those values only. Substitute those values only. 0.85 minus sin r value, sin of 35.2. Okay. So approximately how much value we get it here? Approximately the lateral shift value will be, how much will be? How much will be? Approximately you will get 5.1 centimeter. Okay. This is the formula for value of lateral shift. So how much shifted ma? See, this is the actual direction. Again light ray entering here. Okay, draw the normal. This is second incident angle, I2 normal. 2A na. This is the actual ray, right? So how much displacement takes place between these two? How much displacement will takes place? So this displacement only na we call L. How much will be? 5.1 centimeter. How much will be? 5.1 centimeter. Clear? Next, spherical lens. What is the next topic? Next topic, spherical lenses. Lens is a transparent material. Okay, lens is the transparent material. Lens is a transparent material. We can see with the help of lenses only na. If anybody having any defect means with the help of lenses only we can see. How many faces it has? Two surfaces it has. Let us take, I am taking a biconvex lens. This is also one reflecting surface. This is also another reflecting surface. Okay, where it will be uses in spectacles, glasses and magnifying glasses. If you see that telescope, okay, and microscope, we will use these lenses. Okay, next, if lens has only one spherical surface, the other surface will be plane surface. Remember the point. Okay, one circle surface, that means if I'm taken into two parts here, this is the first part and second part is removed, then how it will be remaining? All are plane only na, plane only na. Okay, next, look at that convex lens. Okay, a double convex lens has two spherical surfaces bulging outward. Look at the diagram. Look at the diagram, how it will be. Two reflecting surfaces. If anybody having any question based on this biconvex lens, having any doubt, I am getting one doubt here. You also get the same doubt. See, if you take a mirror, how many focuses are there? One focus is there. But here, see, how many focuses are there? F1, F1, 2F1, 2F2. Two focuses are there in each side. Each side, two focuses are there. F1, F2 are there. Why it is two focuses? Why it takes place only one focus and mirror? You are also get the same doubt now from the chat box. You are also getting the same doubt or not? Yes or no? Obviously, you will get doubt. Mirror having only one, but lens having two focuses. How it will be? Why it is? Because here the answer is how many reflecting surfaces are there? How many? Tell me. How many surfaces are there? two reflecting surfaces are there. Because of these two focuses will be clear. Okay, if you have to ask your friends also, why lens is having two surfaces, two focus, the answer is that two reflecting surfaces are there. Okay, next, how it will be thicker at the center, okay, and converge parallel. See, it coming from infinity, where it meets, where it where it meet, after traveling through the lens, it meet at one point that we call focus. Okay, converging. Which lens it is that? Converging lens. Why it is converging? Combining at a point. Remember, there concave mirror is converging. Here, convex lens is converging. Clear? Concave mirror, convex lens. Both are same. Both are having same property. That properties we will discuss further. Concave mirror, combining at a point. Convex lens, that is also combining at a point. Okay? Okay, see. Double concave lens. Previously, double convex lens. Okay, double concave lens. So here, this double concave lens having a property of convex mirror. Convex mirror. Here, convex lens is having a property of concave mirror. Remember, to remember easily, convex lens, convex lens is concave mirror properties are there. Okay, concave lens, convex mirror properties are quite opposite. Okay, see, double concave lens has two spherical surfaces curved inward. There curved outward, here curved inward. That is the difference. Curved inward, curved outward, thicker at the edges, and it will be divergent because convex mirror, it is a diverging mirror only. It is a diverging mirror. Here, concave lens, diverging lens. Same like convex mirror. Okay. Okay. Next, a ray parallel to the principal axis. Tell me, we already discussed in session 1. We already discussed in session 1. Okay. If any ray parallel, how it will be? Meet at a focus. Meet at a focus. That we know now. If any light ray parallel. Look at the diagram. Where it started infinity, how this with the principal axis parallelly, where it is meet at focus, whether it is concave or convex, either it is concave or convex lens, if the light rays or infinity or parallel to the principal axis, the first property, okay, first property, parallel means meet at a focus. Clear? Next, Next, light ray passing through the principal focus. Light ray passing through the principal focus. First point is what? Parallel means meet at a focus. And passing through the focus. Passing through the focus. It will be parallel to the principal axis. Na? Quite opposite. Na? We already, how we discussed in a mirrors, the same thing here also going. Okay, there concave mirror, here convex lens. Clear? So, parallel to principal axis, meet at focus. Passing through the focus, meet a parallel to the principal axis. Clear? Next, look at that. Look at that. Passing through optical center. See, this is the optical center of the lens. Passing. No divergence takes place. No deviation takes place. No conversion takes place. Okay. Whatever the lens passing through optical center, no deviations. There also in plane mirror also the same thing. Passing through normal, deviated 180 degrees. Here there is no deviation takes place. If passing through the optical center, no deviation. See, any deviations have you seen? No deviations are occur when light passing through optical center. Remember, if a light ray passing through optical center, no deviations are. Okay. Remember, no deviations when it is possible. if light ray passing through optical center passes through the lens, no deviation. See, you have to identify that where is the object and where the image takes place. We have to see, you have to identify the differences, whether it is lens or mirror. You have to focus on only one thing, where is the object position and where is the image position. You have to see these two things only. Okay, so where is the object and where is the image, compare object position is where and image position where it is exactly. Okay, so here we take in object at infinity. Okay, blindly follow. If object is at infinity, where is the position? Anybody from the comment section? Anybody? Where is the image? F. F. Okay. So which mirror, which lens we are taken here? Convex lens, na? Convex lens. So the convex lens properties, how it will be? It's similar like concave mirror. Okay, the properties of concave mirror and convex lens are similar only. Object at infinity, image at f only. Okay, and coming to the sign convention, what is the u value? U is object, v is image, f is focal length, na? So object distance always negative. Okay, u is always negative. Can you guess why v is positive? Anybody? Anybody? If you know sign conventions, why v is positive? Why v is positive? And there in concave mirror, v also negative. But in convex lens, what about v? V taken positive. Anybody can give the reason from comment section. Also give reason why v is positive in convex lens. Why v is positive? Because see, this is the direction of incident ray. Along the direction of incident ray, what is that? Positive only, na? Opposite to the incident ray, negative. Along the direction of incident ray, positive. Remember, opposite to the direction, negative. Along the direction, positive. That's why v is positive. And f also positive only. F also along the direction, na? That's why f also positive. Okay, so v and f are always positive except one case. That one case, what it is, we will discuss later. Okay, in this only. Next, and what about that nature? What about the nature? It's very important. You should know about the nature also. Which mirror? Concave mirror. We comparing with the convex lens. What we discussed, both are same properties, similar properties. Okay, real, real only. How the image will be inverted, inverted, and size highly diminished. Okay, compare, just comparison with the mirror and lens. If you are going for concave mirror, go for convex lens. Both are similar only. Okay, go for concave mirror, go with the convex lens. Convex mirror, concave lens. Okay, next, tell me, where is the object between infinity and 2f? See, where is the object between infinity and 2f? Where is the image takes place? Between f and 2f. Infinity and object. Beyond c, between p and c. So here also between f and 2f, how the images will be real, inverted, diminished, like concave mirror blindly follow. Like concave mirror. See, at f, at 2f, at 2f, there also at c, it's c only. Okay, it's c, c. Here 2f, 2f. Coming to this point, coming to last three, coming to last three, quite opposite, inverse, inverse. Okay, see, infinity, f. If it is f, where it will be? Infinity only, na? At f, infinity. The object at infinity, image at f. Image at f. Okay. Now see, object at f, image will be infinity, quite opposite. Okay. Between f and o, where is the object? Where is the object? Between optical center and f. See, optical center and f, where the image will be, where the image will be on the same side of the lens. In this case, except in this case, all the cases are real image only. In which case, in concave mirror also, if object takes place between pole and focus, pole and focus, okay, pole is the optical center, f is the focal length, in between these two object is there. So here also the same thing, optical center and f, between these two object is there. What is the image will be? Virtual image. There also behind the screen na. Here same side it is, okay, same side, there it is behind the screen comparison. Here it is same side, in the mirror opposite side, okay, behind the mirror. Which type of image? Virtual, erect, enlarged. Same properties like concave mirror. If you remember concave mirror, you understand about the convex lens. Same, no changes at all. Okay, only changes takes place in sign conventions. There B positive, F also positive. There all are negative, except in one case. Okay. Next, next coming to the concave lens. Okay, concave lens. Concave lens is a concave lens is a convex mirror property. Okay, remember convex mirror property. At F, at infinity, at F only similar. Look at that. Where the light rays are coming from infinity, where it is meet, where it is meet, where it is meet, where it is meet, it meet f no, virtual, right? Okay, and look at the sign conventions, u negative, v negative, f also negative. Okay, f also negative, u negative, v negative, f also negative only. Okay, there u only negative, v f are positive. Clear? Next, coming to the second point, where is the object between optical center and infinity? Okay, between infinity and optical center, where is the image takes place? Where is the image takes place? Image takes place between O and F. There also same na, object at infinity, where the image takes place between P and F. Here O and F. The difference is what? There P, here it is O. That's it. Okay. F and O, virtual, erect, diminished, same thing only. Okay, no need to study about a lens if you understand the mirror, concave mirror and convex mirror properties similar like convex lens, concave lens. Convex lens, concave mirror, both are properties are same except sign convention. Concave lens, convex mirror, same properties are except sign convention. Okay, remember. Next, look at the sign convention. Along the direction positive, opposite to the direction negative, above the principal axis positive, below the principal axis negative. Okay, above the principal axis positive, height coming to the heights only, coming to the height only, you have to check above or below. Above means positive, below means negative. Along the direction of incident ray positive, opposite to the direction of incident ray negative. Remember. Okay, this is for convex lens. And coming to here, coming to along the direction positive only, opposite to the direction negative only, above the principal axis positive, below the principal axis negative. Okay, the sign conventions are same. Along the direction positive, opposite to the direction negative, above the height positive, below the height negative. Clear? Okay. Next, coming to the lens formula and magnification. Lens formula and magnification. So we know mirror formula, right? What is the mirror formula? I'm comparing. See, here I'm reminding that mirror as well as lens. Okay, because in the past section you forget about mirror. Okay, now I'm revising that mirror formula. So 1 by f is equal to 1 by v plus 1 by u. See, this is a mirror formula. Mirror formula. And this is the lens. Compare both. Compare both. Anybody from comment section, compare both lens and mirror, which is changes. Okay, is there any difference in that? Is there any difference in mirror and lens? What difference is there? In lens you have minus, in mirror you have plus, that's it. Okay, y minus y plus, object and image as per sign conventions negative. Here object is negative, image is positive. Clear? Okay, next, it's valid for all spherical lenses. The formula is valid for all spherical. There it is valid for all spherical mirrors. Here it is valid for all spherical lenses. Next, coming to the magnification. What is the use of magnification? How the image will be compared to object size, how the image will be. Whether it is small or whether it is more with respect to the size of the object. Okay, so you need to find out the magnification, means how the image will be compared to the object. Same object, if I see, okay, through the mirror or through the lens, how it will be very small or very big, you have to see. Okay, microscope is there. What is the purpose? We can see that image will be very large and compared to the object. Okay, if I am seeing this object, it will be very huge, image will be. So how the magnification will be compared to the object size, how the image will be. Magnification is nothing but it's only about image with respect to an object. Okay, see here v by u, there will be, if you take a mirror, in mirror we will take minus v by u. Remember, I am explaining both at a time. If you take mirror formula, minus v by u, in the lens v by u only, and heights hi by h naught, that is similar only. Okay, height of the image by height of the object for magnification. Look at the formula. Look at the question. An object of 5 centimeter is placed 20 centimeter away from converging lens. They not mention which lens given. We know concave lens. We know convex lens. We know concave lens. We know. But what they said? Did they mention the two names? Convex lens and concave lens? No, they not mention. But they given a hint na. Which lens it is? Converging. Converging lens. So converging lens means which lens? They given a hint. Which lens? Which lens? Converging lens means which lens ma? Convex lens. By seeing the diagram you may know it. Which lens it is? Okay. Which lens it is that? Convex lens. Okay. So an object 5 centimeter. Okay, 5 centimeter object, height of the object is 5 centimeter, placed 20 centimeter from a converging lens. So from the optical center, what is the object distance? 20 centimeter from the optical center. Okay. Next, focal length of the lens is given. So focal length is how much ma? Plus 10 centimeter, because towards the incident ray direction na, focal length will be plus 10 centimeter. Object distance is minus 20 centimeter. Okay, what we need to find out? Find the position. Find the position. So position means where it is. V value we are going to find out. V. So which formula we take? Which formula we take? Lens formula only na. Anybody lens formula from comment section? Anybody lens formula from comment section? Mirror formula 1 by f is equal to 1 by v plus 1 by u. That we know. Lens formula 1 by f is equal to 1 by v minus 1 by u na. So 1 by f value, focal length value. Focal length value how much they given ma? Focal length is 10 centimeter. 1 by plus 10 is equal to 1 by v minus object distance minus 20 centimeter. Substitute minus 20 centimeter, minus into minus plus 1 by 20. If it will come this side, 1 by 10 minus 1 by 20, that is equal to 1 by v. Guess the answer. Guess the answer. What is the image will be? Anybody from comment section, what is the image will be? Image will be, take LCM, 2 minus 1, 1 by 20 na. So V is equal to plus 20 centimeter. Can you guess anybody from comment section why V value is plus 20? Anybody from comment section why V value is plus 20? Anybody from live why V value is plus 20? Because where the image will be, if object is 20 centimeter, that means image also, image also, image also, image also 20 centimeter only na. Image also 20 centimeter only na. So image distance also 20 centimeter. That means object distance is equal to image distance. It means where is the object? At where is the object? At center. Center of curvature, how it will be? See here also 2f1 is equal to 2f2. 2f1 is equal to 2f2. The problem is solved? No. We have just find out the position and size. We're going to find out the size. What is the size? Huh? Magnification. Who will tell? Magnification. Formula. Formula for magnification. V by U. Remember. V by U. V value plus 20. U value minus 20. Then it will be minus 1. So magnification value is the minus 1 centimeter. But what are we going to find out? Size. Okay. Which one size? Image size. So what is the formula? M is equal to height of the image by height of the object. So magnification value minus 1. Height of the image we don't know. Height of the object they given 5. Then height of the image. So height of the image is equal to minus 5 centimeter. Height of the image. So you will get in height minus. It means inverted. It means inverted. Okay. It means inverted image. Okay. Below the principal axis, now this is the principal axis, right? This is the principal axis. So below the principal axis, 5 centimeter height. 5 centimeter height. Below the principal axis is what? Minus 5 centimeter. Okay. Minus 5 centimeter. So height of the image is minus centimeter. Next, nature of the image, real. Nature of the image, real and inverted. Same size. Okay. Because it object distance is equal to image distance. 2f1 is equal to 2f2. Same size. Nature of the image, real and inverted. Okay. Yeah. Can we go for next one? So again, take the power of lens. So what is mean by the power of lens? What is mean by power of lens? So what is the use of a power of lens? Okay. So if you're taking a lens now, if you're taking a lens means how you calculate that power of lens. So what is first of all what is mean by the power of lens? How combining a light rays, okay, how diverging a light rays through a lens. Okay, for example, if I'm taking a convex lens, how the light rays are combining through that lens? What is the power? How much it will be? How many light rays are combining? Okay, for example, if someone is going through the through, through back, I will stop. Okay, how many are stopping? That is my power. Okay, see here also, if I'm taking a convex lens, if I'm taking a convex lens, how many light rays are combining by this? Okay, how many light rays are combining by this? How many light rays are by combining this? If I'm taking one more, it will be different na. So this is having one power. Okay, this is having one power. So how can you calculate the power of that? Okay, how it is combining or how it is diverging? Based on that we will calculate a power. So especially the power depends on focal length. Especially the power depends on the focal length of the lens. Okay, so that unit, SI unit, remember the SI unit of the power is diopter. Okay, what is the SI unit? Pronounce with me, diopter. Okay, diopter. And the focal length will take in meters only. The focal length we always take in meters. So P is equal to 1 by m meter. So 1 by meter what we call diopter. Okay, diopter. Diopter. Okay. Yeah. Next, look at the problem. Two lenses. One of the focal length is 20 centimeter. So f1 is equal to 20 centimeter. So did they mention which lens it is? Convex lens. For the convex lens, what is the f1 value? 20 centimeter. Okay, and another focal length is minus 15 centimeter. So they only given sign convention. Which lens it is? F2. F2 minus 15 centimeter. With the sign convention, they given a values. F1 is 20. That means plus 20. Which lens it is? That convex lens. Okay, and one more. One more is that concave lens. That sign convention also they only given the value minus 15 centimeter or placed in contact. Okay, how these two will be? One convex lens with the focus of 20 centimeter and another one will be concave lens. Both are in contact. Optical center O O. Okay, both are placed in contact. What is the focal length and power of the accommodation? So focal length of which one? This is having a one focal length, that is f1, and concave also having focal length f2. So the combination of these two we call it is that focal length. Okay, 1 by f is equal to 1 by f1 plus 1 by f2. 1 by f1 value, f1 is what? 1 by plus 20, f2 value minus 1 by 15. Take LCM, 20, 50 LCM. Anybody from the comment section? Anybody from the comment section? LCM for 20 and 15 LCM. Anybody? How much? LCM 20 and 15. 16. How many times? 3 times. And here 4 times. 3 minus 4 minus 1 by 16. 1 by f is equal to minus 1 by 16. Minus you will get for which one? For which one? For which one you will get minus focal length ma? Negative. Where you will get? Concave lens you will get negative. Concave lens you will get negative sign convention. Convex lens is always positive. Is it na? Is it na? Right? So F value how much? F value is minus 60. Combination of focal length is that minus 60 centimeter. The problem is over. No, just we find out focal length only. Next, which one we are going to find out? Anybody from comment section? Anybody? 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 What we going to find out? Power. What are we going to find out? Power of this combined. Power of the combined, right? So power P. Tell me, power depends upon which one? Anybody from comment section or anybody? Power depends on what? Hmm? Power depends on 1 by F only na. Yes, right? Power depends on 1 by F only. What is the combination of the focal length ma? 100 by focal length. How much value? 60 minus 60. How much value you will get? 0, 0. How much value? 10 by 6. Hmm? 0, 0 cancel na. 10 by 6 you will get. Means how many times? 10, 6 mein. 1 times. Remaining 4 is there. Right? 1.6 is the 1.6 diopter. Minus 1.6 diopter is the power of the combination of concave and convex lens. Clear? Clear? Remember na? Power is equal to 1 by f. That is the formula to find out a power of the lens. Clear? Next. Yeah. We came to end of the section. What you learned in the section, once again recapitulate very quickly. Okay. Introduction of refraction. Introduction. Refraction, when it takes place, very simple. Anybody from comment section? Refraction means what? Refraction means what? Bending. Simply refraction means bending. When it takes place with the one medium, is it possible bending? No. Two mediums are required. For bending, two mediums are required. Either 1 to 2 it travel or 2 to 1 it is travel. Okay. Laws of refraction. Laws of refraction. Incident ray, refracted ray, normal lies in the same plane. That is laws of refraction. And one more laws of refraction. Very important one is what? Snell's law. Snell's law. Remember na? Snell's law. Ratio of sin I by sin R is equal to constant. Sin I by sin R is equal to constant. This constant we called refractive index. That refractive index only will decide how much bending or how much not bending. Okay, away from the normal or towards the normal. Okay, towards the normal or away from the normal. Who will decide? Refractive index will decide. Clear? Clear? Next, refraction by spherical lenses. How many lenses are there? Convex lens is there, convex lens is there, concave lens is there. Okay, so convex lens properties are just like concave mirror, and concave lens properties are just like convex mirror. If you remember the concave mirror and convex mirror, lens are easy. Okay, next, lens formula. Lens formula, 1 by f is equal to 1 by b plus or minus 1 by u. If you take a mirror, this is for lens. If you take a mirror formula, plus will come. This is the mirror formula. Okay, at a time I am giving two, lens and as well as mirror. Don't confuse. If you take mirror, plus will come. If you take lens, minus will come. Okay, next, power of lens. What is the power? What is the power of the lens? How combination power, diverging power, combination power, diverging power, combining power, diverging power. Okay, if two friends are fight, what you will do? Combine. You have a ability to do that. Okay, that is a power. Combination power and diverging power. If you want to separate, for that also you need power. Okay, combination power, diverging power. So power of lens. What is the unit, ma? Diopter. Okay, what is the unit? Diopter. And power of lens mainly depends on focal length of the lens. Clear? Thank you.